will be a star freelancer. Learn new skills. Set your goals. Increase your skills. Browse over 100 plus videos and ebooks. Jump to starfreelancer.eu.
Let's do right justification. Just as we consider the left justification, we also have what? Right justification, which I actually explained earlier. If it's somewhere here, looking at where it is in this bar, this is right. When it is here, center, here is left. The work of this is to push it to the right. Okay, if I apply this right justification on this, then I put the number of space that should be before the string. Let's say I say 30. You see what he has done? He gave me 30 spaces before the string. Okay, so you can also decide to pad this place with any T of your choice, like say P. You can pad it like say this. Let's look at replace. Just as the name goes, we use this to replace a substring from the target string. If I put here now this, I have to tell the system what I want to replace. Assume I want to replace 4. I'll just tell the system I want to replace 4 with whatever I want to put there. Let me just say UU. See, this 4 has been replaced with what? This. Okay, I copy this again and put it here. What if I want to replace cool with what? Let's say 1 people. See, all of them are what? Replaced. What if I only want to replace 1? Just 1. I will tell the system that it's only 1 I want to replace. So the first one is replaced. This and this were not replaced. If I want to replace 2, you see, this and this replace. This was not replaced because there are 3 numbers. Hope this is understood. Thank you for viewing. Let's look at strip method. This removes white space from both the right and the right side of a string. For instance, if I have something like this, as you can see, we have white space here. We also have white space here. If I apply this on it, you see both this white space and this white space automatically removed just by applying this. Okay, Python recognizes a new line as a white space. For instance, if I put new line here now and I apply the strip method, definitely that will go to. The same thing go with tab. If this is tab, for instance, say this, you see both the tab and this are both removed because strip removes both the white space, new line, and tab from a string from both right and what and left hand side. Hope this is understood. Thank you for viewing. Now let's look at our strip, that is right strip. That is to say, remove any white space at the right hand side of a string. For instance, I say, let me just put anything I want to put here, just anything. I say dot arrow strip. Let me also put white space here. Let's run this. You see, it's the one at the right side that is removed. See, this one is still left there. Okay, the same thing goes for tab. If I put a tab here and I put a tab here, for instance, you find that it's the one on the right side that is removed. Okay, if I also put new line, let me say I also put a new line here, you see that this new line will be removed. This will also be removed. Let me also include the normal white space. You find that all this one will be removed, but none of this will be removed because this is dealing with what? Right strip. Okay, you see, all are removed because this is for right strip. Hope this is understood. Thank you for viewing. Now let's look at left strip. If I put any string, this will remove white space at the left hand side of this string. If I put both of this like this, then I say dot left strip. You see, it's the one on the left hand side that is removed. Okay, now Let's also try this with tab. Let's include tab, include new line on both sides. Remember, Python recognize tab and new line as what? White space. So let's apply this. You see, it's all this way stripped off because they are at the left-hand side of this string. All this is understood. Thank you for viewing. Now let's look at expand tab. Just look at this. Let's say A, B, C, D. This is string. \T is tab. If I apply this method on this string, it simply say remove this tab. I put white space. You see? You see that here is a white space in place of this. That is the work of this. Okay. Now let's run this again, but we're going to put this tab in many places. Let's say everywhere. Now let's run it. You see? All the tab replaced with what? White space. White spaces. Okay, but you are asked, how many spaces are here? That is the default. But if you want to put a space by yourself, say 2, 3 by yourself, you can put. If you want to put 10, you can put. Let's look at Z field. Z field simply means zero field. For instance, I have this. If I put the Z field, I'm telling the system to put 0 for me here. I have to tell the system the number of zeros, but I need to count this inclusive. These are 4 characters. If I put 4 characters, that means I will still have the same thing. So I need to increase it. Assume I increase it by 1, that is 5. It becomes only 1 0 that will be filled to the left hand side. If I put 6 now, 2 will be filled because it's removing this from this. They use the remaining one for 0. Okay. What if I do something like this now? I say dot Z field. Let's say 10. You see? Put it 0. But before it does that, say 1, 2, 3, 4, 5. Then the remaining one for 0, 5 zeros. Okay? Now let me give you another instance. If I have minus this, then I say Z field. Field 0 for me. Put 20 for instance. This negative will not be removed. The 0 will come before this negative. Let's see. You see? Even if I put positive here, positive sign, the same thing goes that positive sign will come before this 0. And don't forget, these are 5 first. And you count this one, you find out what they are 15 in number, plus this. Okay? All this is understood uses Z field to put 0 before the string that is being targeted. Now let's look at partition. Assume I do something like this. I say dot whatever. Then I say dot partition. I have to tell the system where it should partition this string. That's why I'm putting this delimiter. If I put it here now, you see, it is now partitioned here. This one become one string. A string, a what? A string. Okay, that's the work of partition. You can use anything. For instance, I can also do something like this by save. Let me just put whatever I want to put. Say I want to partition at U. Partition. You see, this is separated. The first U, because there's what? Another U here. You can even want to partition more than one. Like if you want to partition with UF or FG. Let's say FG. Assume I do something like this. Then what I put for the partition is not even there. See, it will take all of this with this and this. If what you ask the system to use for partitioning is not found in the string, it doesn't matter what you put here. As long as it is not there, it will always come out like this. Now let's look at R partition. What is the difference between R partition and normal partition? What this does is it divides the string based on the separator. But this time, it's only going to separate from the one on the right hand side if the separator is in the string. For instance, if I say .r partition, then I tell the system that this is the separator. Okay? Remember, this is here and also here. Because of this R, it's telling the system use the one closer to the right hand side. If I run this now, you see, this is the one that is used at the separator, which is this one. But if it was a normal separator, you see, this one will be used. The first one will be used. But if you want the right hand side one to be used, you do it like this. This is just the meaning. Let's try another one. Let's just write anything. Let me put a share. Let me say I'll use this one. A share 2. Then I say dot separator. I use this one. If I use this now, this will be used instead of this. If I want this one to be used, simply remove this. This will be used. Hope this is understood. Thank you for viewing. Let's look at R split. What does it do? Look at this. This is a quick course on Python dot R split. If I do this, the system will use this space as a form of delimiter to do the separation between these substrings. They convert everything to list. Let's see. You see, when you see this now, it means that what? This is now a list. And it's using this space as delimiter to separate the substring from each other. Okay? I'm going to copy this again, paste here. But this time, I want to specify that the system should help me to use another form of separator. Let me say dot. So I'm telling the system to use dot as a separator. This option is allowed. The same thing is achieved. You can put anything you want to put as what? The separator. What you can also do, you can tell the system that what? This is what? Separator is equals to this. You see, achieve the same result, just as if you never put this. The system recognizes that. I'm going to copy this again, paste here. But this time, I want to tell the system that I only want you to do two separation. And if you tell the system such a thing, it will start from the right, going towards the left. So I will say, comma, I want the option of what? Mass split is equals to 2, for instance. You see, all these are still joined together, but these two are used as separators, starting from the right hand side, moving like this. The first one, then the second one. You can see 2. If I put 1 here, only one will be used. If I put 4 here, if I put 4 here, 4 will be used. Let's try another thing. Assume I say www.example.com. And I say R split. This time, I want you to use separator as what? Dot. You see? All this one are done. If I say I only want mass separator, mass split, mass split equals to this. Mass split equals to 1. You see, only this one is what? Done. Only this one is what? Separated. Because of what? The limitation here. If I put 2, definitely. So let me also give you another variation. If I say -1, you see everything separated. -1 simply means separate everything. There's no limit. Okay? If I put dots here, for instance, just for practice purpose, I still leave it like this, all of them. This one is equivalent to, this is equivalent to where you don't even put anything. Same. You want to put it, you put it. It's the same thing as if you've not put it at all. Hope this is understood. Thank you for viewing. This and arrow split, they behave the same. The only difference is that if the maximum split, that is the mass split, is specified, split will be counted from left instead of right. Remember, we are doing arrow split. When maximum split is specified, the count is start from right hand side. But if you want it to start from left hand side, use split. Let's see. If I do this, I say, okay, I want to put dot here now. I also want to put a dot here. I say dot split. Then I tell the system that use this one as what? As a delimiter. If I say comma, I say mass split is equals to 1. You see, it's using the 1 at the left-hand side. This one was ignored. If I had put arrow split now, you see, it is the 1 on the right-hand side that's used. Let me undo this, run this, copy this, put it here, put arrow split here, then we can compare. As you can see the two, when you use normal split, the 1 at the left-hand side is used. When you use the arrow split, it is the 1 at the right-hand side that will be used. It doesn't matter the number they are, even though there are 3 numbers. See? See? It doesn't matter, okay? The next thing we're going to do now, we're going to run this. As okay, what if this maximum split is not specified? We run this, we have this. Let's also copy this now and go for just split. Is there any difference here? There's no difference. It is the same output you get from here, you get from here. But if you want different result, then specify the what? The mass split. I see the output. If the mass split is going with normal split, the 1 on the right hand side, that the separator will be used. But if you use the arrow split, it is the separator on the right hand side that will be used. Hope this is understood. Thank you for viewing. Now let's look at split lines. Let's see. If I give this whatever, then for instance, I put a boundary such as new line. If I say dot split line, this is telling the system that the splitting should be done with this. You see? This is not only the escape sequence we have in Python. We have this as carried return, for instance. Let me also put, if I run this, see, there was a split here, there was another split here. That is the work of the split lines. So these lines are the boundaries. If you want to join the two together, like I put arrow here now, if I remove this from here, for instance, it is what? Split this, then take this between here. There is no substring. Put what? This quotation mark. I continue what? The splitting. So whenever you want to use this, use them along with what? This escape sequence. One thing I must let you know is that if you want to keep this escape sequence, just put here true. If I put true now, though the splitting will still continue, but it will be done with these two routine. If I copy this, for instance, the first one, put it here, I put true here. True mean keep this guy. So the splitting should be this and this. You see now the way it is done. Okay. Let's look at format. What does it do? It is used to interpolate a variable into a string. How do I mean? If I say sex is equals to male, for instance, then I say name is equals to Peter. These are two variables. Now I want to interpolate this variable into a string. What string should be that? I want to write like this. Peter is a male, but I want to interpolate this into this variable. So what I will do, I will remove this from here. I also remove this from here. Okay, the first and second. Then I will say dot format. Inside this place now, we take Peter, who is supposed to be here. I put Peter here. And I take this, the second one, and I put it here. If I enter, you see, it's interpolated this variable into this what? String. So the first one now, we move its value to this place. While the second one, its value come to this place. Now let's look at f string. Look at this. If I say h is equals to Peter, I say m is equals to school. To use f string is like using the format. All you need to do is to put f before the string you want to use it in. For instance, I say curly bracket h goes to another curly bracket m. What am I trying to do? I want to insert this here, then insert this in place of m. With this f, I can do that. Let's run. You see? Peter goes to school because I put F here, which is like what? The format. Okay? So with this, I can position these, the variables, inside the curly bracket, telling the system that I want to use the values in place of what? The variables. Hope this is understood. Thank you for viewing. Now let's look at its ASCII. What does it do? This checks if all the characters in a string conform to ASCII. That is, if they are included in ASCII. Remember this ASCII? If you Google it, look at ASCII characters like P, Q, all these ones. So any character that is not here, that's not among these characters, look at C, C3, C #, that's not among these characters. When you check, it will return false. And if they are here, or if it's here, it will return true. And let's see. If I ask the system, assume I say you are good. I say check for me if everything here is ASCII. Say it's true. If I check this, false. This is not part of ASCII character. Okay, I check another one. Let me see. Odd V. Is ASCII? False. Okay, let's check this. Is ASCII? See? True. You use is ASCII to confirm if all the characters in a string conform to ASCII characters. Correct the following with the necessary quotes and create a string type in Python for it. That is, James told me Kate is a caring person. Okay, first of all, we need to grammatically correct this. That is to say, this. James told me Kate is a caring person. If we want to convert this whole thing to string, we can't use this double quote anymore like this. No. We have to use what? A single quote, which is different from this one. That means with this is also part of what? The string. Okay? If we go the other way around by using double quote, the system will be confused. Okay? If you choose to put single quote here, then what will be here now will be what? Double quotes. Hope you understand this. So if I assign this to, let's say, statement. If I say what type of data is this to statement, this is a string. So if I put the statement, I will have James told me Kate is a caring person. But if you try to do something like this, let's say 2 equals 2. Let's take this. Let's still put double quote. Let's run it. See, the system is complaining that it can't be done like this. Hope you understand this. Thank you for viewing. How would you fetch t from this string? Okay, that's to say st is equals to Python. Can run it. So how can I get t from here? To do that, say st, what position? This 0, 1, 2. Just put 2 here. See, that is how to get t. Because I was able to get the location. That is the index where the t is located. Once I get that, I use this. I was able to fetch it. If you like, you can assign this to another variable. Then you cannot call that variable to give you what? The value of t. Hope you understand this. Thank you for viewing. You are required to fetch ability from I have the ability to learn Python. That is to say, if I say C is equals to this, I want to get this out of this place. So start from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you start from 11, 12, 13, 14, 15, 16, 17. I should not get to 18. I should start from 11, but don't get to 18. See? Starting from 0, this position is what? 11. Here is 17. But if I put 17, it means that y will be removed. I will say, okay, don't get to this place because here is where you should start from. Here is where you should get to. Hope this is understood. Thank you for viewing. You are required to fetch this from this string. Why is this a string? Because of the double quote. So I copy this now. Let's say v is equals to this. That means this is v. We are required to get this. Let's see the pattern. That means start from beginning. Got 8, got this 5, got this 5. That means it's going by what? The first one, 1, 2, 3. Okay, 1, 2, 3, 1, 2, 3. That's to say, v start from the first one to the end. To the end means don't put anything here. If I do like this, I mean take everything from beginning to the end. If you see this place is empty, it means to the end, okay? Or you can decide to put by counting. But if you leave this place blank, I mean this last place blank, it means to the end. If you make this first place blank, it means from beginning. You can also do same thing. You have similar result. If I take this now, put here, same thing. Now, if I put the second column, it means I want to define the stride. As you can see, the stride is a stride of what? 3. That is to say, first one, 1, 2, 3. That's 8. To have this, 1, 2, 3, 1, 2, 3. So if I put 3 here now, it means I'm having exactly that. What if we are asked to get this thing in reverse order? 5, 5, 8, 4. That is opposite direction. That is to say, we start from the end, 1, 2, 3, 1, 2, 3, 1, 2, 3. In a case like this, it's still the same thing. You have to put negative here. That means you have to start from what? The right hand side. Remember, this means start from where? The left hand side. This means start from where? The right hand side, the opposite direction. If I drop this now, you see, I'm having this. 5, 5, 8, 4. This is negative movement, while the first one was positive movement. From left to right. This one is what? From right to left. Given f equals to this, programming, get programming in 3 places with space in between them. Okay, let's take this. We run to f is equals to this. How can we realize this? All we can do is to simply say f multiplied by 3. If we do this, we'll not be able to have this space. So how do we put the space? If you want to put the space, you can simply do something like this. Then we put the space. You see? But another issue now is that there's a space here which was not asked. Okay? It means to realize that we have to remove this. We put F here, the plus, another F, there's space, a plus between them, then we put plus. Now we have exactly what we are asked to get. Okay? If Luke or Kate is in I met Kate. Okay? Let's say P equals to I met Kate. You say what? Luke in P first. Let's try Kate. Kate in P. This is true. That means it's only Kate that is here. Another thing I want you to know, if I copy this now, I put small letter k here. See, it's false because Python is what? Case sensitive. This small letter k and capital letter K are not the same. You are given T equals to this quarter. What would you do to get quarter? Meaning the first and the last character converted to uppercase. This means that if you are given any string, what would you do to make the first and last character uppercase? Let's see. We said what? T is equals to quarter. Okay, if I put in, I have this. We want to convert the first and last character to uppercase. That is to say, the first character, which is located at this index, we want to move it to what? Uppercase. That is 1. Every other character before the last character will remain as they are. All this should remain what? The way they are. And to achieve that, we simply say T from this position to this position. That is before the last character. And last character means -1. And remember, anything you put here, it means you should not get to that place. You should not get to the last one. I mean, start from here. T, this place. You start from what is here, which is 1, but do not get to the last one. Then the last one is this. What do we do with the last one? Still convert to what? Uppercase. Let's run now. See? The first converted to upper. The last converted to upper, all remain the same. We are not doing anything to them. Then we have this. So whenever you are given any string to achieve something like this, simply do this. You are given www.python.com and asked to remove www.and.com. What would you do? Okay, you are given this string. This is a string you are given, and you are asked to remove this and this. What are you going to do? Simply say .else strip, that is left aside. Then you put this. Whatever output you will get from here, also remove R strip. Then you put this. Then you run. For the right hand side, then you run it. You see now? This is removed from the left, while this is removed from the right. Now we have Python. Is it true that strings are immutable? If yes or no, explain. Let's just see y equals to a string. Let's say the name of the string is Python. Then let's check the address of this y. Okay, this is the address. When we say something is immutable, it means that you cannot change that particular thing. Or if we say a string is immutable, it means the value in that variable can be changed. How are we going to know if this particular string is immutable? If we change any of the string and we check the address of y, the address still remains the same. We say what? It is mutable. It allows changes. But if after changing any of the character, for instance, we are having a different address, it means that a new string has been created, not the old one. Because this particular one will remain here forever. Okay, now let's see. Let's change the value of y by saying y is equals to, this time let's just say Python. We enter. If we check the address now, we find that what is giving us what? The different address. It means this one is no longer in y. A new one has been created. It means that this one is still in this location. We just took y from this location and moved it to another location. But this one, that is Python, is still there. Okay? If you don't agree, let's try another one. If we say y1 is equals to Java, say y2 is equals to Python. Okay? Now, I say this is y1, I say this is y2. Let me try to add the value of y2 to y1. Before I do that, let me check the ID. ID of y1 is this. Now let me try to add the value of y2 to y1. I will do it like this. Saying y1 is equals to the old value of y1 plus the new value I want to add, which is this. Let me put this here. Now let's check y1 now. We have this Java Python. Now let's check the address now of y1. You see, it's a different address entirely. This was the previous address of y1. Here, this is a new address, which is different. It means that whatever that was y1 before, see, is still here. But this time, because we are changing the value, which is this Java, you are changing it to Java Python. Therefore, the system will not hold this new value in the same location. It will change it to another location. If it has allowed us to use the same address to store this, we say what? It is immutable. Because while we were trying to change the value, it did not allow us to store the value here. It moved it to a different location. We say what? It's not allowed changes. It is what? Immutable. Therefore, we can conclude categorically that strings are immutable. Hope this is understood. Thank you for viewing. How would you concatenate two strings? You can do this using the additional operator, that is the plus operator. If I have a string that says this is, for instance, I can use plus here to add it to another string, a ball, for instance. So I can use this to add this string and this string. What if I have y equals to, I love programming. Then if I want to concatenate another string to this, I can easily say y plus in Python, for instance. See, I love programming in Python. So using the plus sign, you can actually achieve concatenation of two or more strings. Hope this is understood. Thank you for viewing. You are given James is here to get James is there. How? If you want to achieve this, we are talking about replacing this with there. You are given A is equals to this. Now you are asked to remove this. All you need to do is say A dot replace. You put here, then you put there. See? We are asking the system to replace here with there. Then you drop it. See? James is there. If you put A now, A still remains the same. If you actually want to have this registered, you can say, okay, for instance, B is equals to this. So if you put B here now, we have what? James is there. Hope this is understood. Thank you for viewing. How would you check if a string contains a substring? That is to say, this is Python programming. How would you know or check if this string has Python, has programming, has this in it? The way to do this is to use the in operator. You see Python in this. It says true. If you check Pythons, which is not here, you have what? False. This is how to check if a particular substring is in a string. Let's try another one. Let's say U equals to the boys are coming home. So I can say boys in U. Says true. If I say girls in U, says false. Hope this is understood. Use in to confirm the existence of a substring in a string. Demonstrate how you will use a string for Dan and Fami in the string Dan loves Fami. Okay. First of all, let's say name is equals to Dan. Profession is equals to Fami. Then if we want to use a string, say F, then we put name loves profession. Okay. Now in place of this, the value will be put there, and in place of this value will be put there. So let's see. You see, Dan loves Fami. So that's the work of F string. F string. Use the curly bracket and variable name combination to call in the value of the variable you are targeting. Hope this demonstration explains how to use the F string to you. Thank you for viewing. Using Python, check which of these strings contain numeric values. This first one or the second one. What this is trying to test is how to use is numeric. So let's see. The first one is 790. So let's check if they are all what? Numeric. Is numeric. It's true. Let's check this too. Is numeric. It's false. So you want to check if a string contains numeric value. Simply use this method called what? Is numeric. Is it possible to add string and integer together in Python? In some other languages, it is possible, but in Python, it is not possible because it's going to return type error. Let's see. If I say, for instance, hello world plus, let's say 300, you see, can only have string, not integer, type error. So in Python, you cannot add string to integer or even float. Hope this is understood. Thank you for viewing. How many characters in this string? Everything is moving very fast. This is testing your understanding of how to use the length function. So if we take this, I put here, we can know the length of this string, 30 in number. If I add another one, it's now what? 45. You are given, these are the names, Peter, James, Ahmed. What would you do to separate the names from each other using Python? We want this name to be separated. That is to say, Peter should be separated, James should be separated, and Ahmed should be separated. If you want to do that, you simply use what? Split line. Whenever there is this, that is, new line, or tab, or space, you can use split line to separate these names. And this one will disappear. Let's see. If I have this, I can easily apply dot split lines. See, these are the names, Peter, James, and Ahmed. The separation. This challenge is just testing your understanding of what? Split line. Hope this is understood. Thank you for viewing. You are given Python and you are asked to reverse it. Okay, you are given this string and asked to reverse it. Simply say reversed, then you put Python. If you run it like this, you can't get it reversed. It will only show you reverse at this location. To actually get it reversed, you must put join here. That is to say, join this. And whenever you use join, you must tell join what it should be looking at. What should I be looking at here? I will tell join not to look at anything. Just reverse it. If I run this now, you see, starting from here now, going towards the side. That is this. This is how to reverse a string in Python. Hope this is understood. Thank you for viewing. Remove the white space from the right, left, and both sides of the following strings. Python programming, there's a space here. This one, there's a space here. There are space here and here. So let's start with this. Okay, let's start with this. To remove white space from the right hand side, we use rstrip. That is to say, Python programming, this space, whatever space, irrespective of how long it is, just simply say dot rstrip. See, the white space is removed. Okay, if you want to remove for this other side, that is the left hand side, you simply put what? The L strip. Okay, see, remove now. If you want to remove from both sides, let's just put this one as new. This one is R. This one is left. Then we take this one for both sides. You simply do what? You do strip. So these are the three ways. For right, you use R strip. For left, you use S strip. For both sides, you use strip. Hope this is understood. Thank you for viewing. The same string, education is the key, was created twice and assigned to two different variable names. Same thing was done for string book. Would Python store this in different memory locations? Demonstrate your result. Okay, the first is S is equals to education is the key. Okay, we have this. Then let's put it in another location. Let's say D. So the only way to know if they are located in the same location is to say what? ID S. That is the memory location of this one. ID D. That is the memory location of this one. As you can see, they are located at different locations. Okay, let's say for this one, just with one string. Let's say P is equals to book. Let's say T is equals to book. Now let's check P. Okay, that is the address. For T, see? Now we found that book at P, book at T are what? In the same location. If you have one string stored with different variable names, Python will use one location for all of them. Look at this. We have book. P is pointing at it. T is pointing at it. If you like, create more. They will all be pointing at book. Same location. This is their location. It will not change. But if it is more than one string, like book is good. For instance, if I put book is good, I put here too, book is good. Definitely, Python will use different address for them. If I run this now, you see, this is a different address, this is a different address. If I remove this, for instance, I say, okay, now I want to put good. Let me change here. Okay, I run this, I run this. If you run this again, you find out what? Python is now using what? The same address for P and T. Hope this is understood. Thank you for viewing. Where is the first and last hello located in this string? Is hello actually hello? Where is this hello and this hello located? You need to search and give your results. Okay, this is a string. Let's see, S is equals to this. Is hello actually hello? To search for first hello, you have to use find. That is S dot find. Then you put the string hello. It says what? 3. That is 0, 1, 2, 3. How do we get this? To get this, you use what? rfind. Mean right find. It says what? 18. That is this one. Located what? At index 18. Find, we search for a substring starting from the left hand side. Why rfind, we search for a substring starting from the right hand side. Hope this is understood. Thank you for viewing. If you are given two strings, how would you know if they have the same identity? Also, how would you test if the two strings are equal? We are talking about identity and what? Equality. What is the difference between these two? When you want to test for identity, we use is. When you want to check for equality, you use the double equal to. If I say R is equals to this is good. This is string, right? And the address of this string is this. So this string is located here in the memory. Okay? If I say now R2 is equals to R, it means if I put R and put R2, they have the same strings. Okay? Now let's check for the ID of R2. You find that this is the address, same address. Why? Because these two, they are pointing to the same location. We have a location, and what is there is this is good. It's in this location. And this is the address of this location. Arrow is pointing towards it. Arrow is pointing to this location. Arrow 2 is also pointing to this location. That is the meaning of what we have just done. Saying what? Arrow 2 is equals to arrow. Is pointing to this location. So the address that is here is what both of them will show when you check for what? Their address. Okay? If I'm asked if arrow and arrow 2 are identical, I will simply say yes. So I can easily say arrow is arrow 2. You see, it's true. It's also true that arrow is equals to arrow 2. It's true because they have the same value. So identity is talking about the address location. Why the double equal to is checking the values, if they are equal values. Okay? Now let me get R3. What I will put here now, I will say this is bad. This is bad. So let me check the ID of R3. It's a different address. Okay? If I say, for instance, R3 is equals to R1, you agree with me, they are not in the same location. This address is different from this address, or this address is not true. You would have changed this one. It's not true. If I say it's not true. Okay, what I will do now, go back and say R4 is equals to this is good. Okay? Remember, this R4 now, the value there is equals to this R, which is this is good. Just like this one is this is bad. And we already know that R2 is pointed towards R1. So we are going to check now. Let's see what is in R again. Let's confirm it. R is what? This. R4 is what? This. Okay, same. You can see they have the same value, but they have different address because they are not pointing to the same location. Let me show you. If I say ID arrow, we have this. ID R4, we have this. Okay, you see two different locations. Okay, but you can see that the value in those locations, they are equal. So with this one, I can say these two are equal because they have the same value. That is, R is equals to R4. You say it's true because they have the same value. But you cannot say R is R4 because they are not located in the same location. They are not in the same address. They have different address. See, it's false. So note that thing that if you have a location, you put a string, and the string is, for instance, hello. I say the address is 2478. If I say, for instance, that K is equals to this, and I say K is equals to P. So this P will be pointing toward this address too. If you want to check the ID of this P, it will give you this. If you want to check the ID of this K, it will give you this. It means what? You can say K is P because they are located in the same address. You can also say K is equal to P because they have the same value. But if I go ahead and say K, N is equals to LO. Remember, I did not do something like this. I did not say K is equals to this. I say it's equals to LO. It will still give me the same thing. Remember, I show you something that when you use one string, the system will always put them in the same location. One string. But if I say LOU, for instance, this, they can never be in the same address. Let me show you again. If I say, for instance, T is equals to LO, let me also say Y is equals to LO. So if I check the address of these two, check the address of this second one, see they have the same address because it's only one substring, same substring. That's why the system is putting them in the same location. So these two can be considered equal. They have the same identity. They are also equal because they are located in the same address. This one qualifies this identity. And if you use is, remember is used to check if they are located in the same address. You also find that they are equal because they have the same value. Okay. If I also say J is equals to, for instance, Y, if I check the address of J, it's still the same address because it's just one value. Okay, now let me go further now. I say, okay, Z is equals to hello me. I say D is equals to hello me. Okay, I say L is equals to hello me. You find that they will not be in the same location. If I put Z here now, that is the address. If I say ID again, I put D. See, different address. If I put ID, and now, different address. See, different addresses. Because this is more than one substring. Okay, so if I check for their equality now, equality, they are all equal because they have the same value. So I can easily say Z is equals to D and is equals to L. Say it's true. If you say Z is equals to D, true, or Z is equals to L, it's true. But if you say Z is L, as you can see this, I say Z is L. You see? It's false. Why? Because they are in different address location. So they don't have the same identity because identity which is tested by is used to check if they are located in the same place in the memory. But if you want to check for equality, when you use this, you are only referring to the value, the string that is stored in that location. If you want to check for identity, you use what? Is. If you want to check for equality, you use a double equal to. Hope this is understood. Thank you for viewing. How do you check if all characters in a string are lower cases? That is, how do you check if they are all lower cases? If what comes to your mind is lower, if this is what comes to your mind, then you are correct. If one of them is capital letter, say it's false. Everything must be lowercase before it returns true. Hope this is understood. Thank you for viewing. You are given "it is raining today" and asked to convert to uppercase and lowercase. You can see the way it is done. There is no pattern. They are not all lower, they are not all upper, but you are asked to convert this to uppercase and lowercase. So to convert to uppercase, we simply do dot upper. And to convert to lowercase, we simply do lower. These are the two methods to convert any string to all upper and to all lower. How would you interpolate W equals to weight and num equals to 34 into this string? The weight of the bag is 34 kg. Whenever you want to interpolate, you simply get the string. You remove whatever you want to interpolate. Use curly bracket to replace it. This one replaced by curly bracket. Then you say dot format. Dot format, you take this variable, which is W. Then you take this variable, which is num. That means this will move to this place. The value of this will move to this place. Why the value of this will come to this place. If I run this now, okay, sorry about that. The reason why it's giving us errors because Python does not know what is W and what is num. So I run this now, then I run num equals to 34. So then I can now run this comfortably. So you can see now, in this place, the system knows that I am telling it to move the value in this variable to this place. The first one for first one, the second one to what? To this place. And you can see weight and 34. This and this. Hope this is understood. Thank you for viewing. How would you know if each word in a string begins with an uppercase? That is to say, if I have this, this is a good class. How do you know if each of these begins with what? A capital letter. To know, you simply use is title. That means you are asking the system. Why it is very important. You can have millions of words in a string, and you cannot check that manually. If I add the system, say false, because some of them start with what? Small letters. Okay, if I copy this, I bring it here. Let me change this one to capital letter, capital letter, capital letter, capital letter. If I check now, it says true. If I copy this again, I put it here. I say, okay, here is A. It's false because this A starts with small letter. So everything, each of the word must start with what? Capital letter. But these that are manually changed, remember the first one here, it came out false. False, right? If I want to change this one, I can decide to change this one false. It's okay. Change everything to title. What is the work of title? The work of title is to convert everything here to capital letter. Okay, let's see that first. See, done. That's the work. So I can actually apply this on it now. That means you first of all help me convert everything here to capital letter. Then whatever you have, which is this, check if everything is what? Capital letter. What I'm doing here is, this guy should help me to change all this to capital letter. After you have done that, you have something like this. Then this one will now check if actually what I was expecting is what he gave me. So if I copy this, for instance, I place here, say it's true. Hope you understand what you have done. Using its title to check if a string has all its words begin with a capital letter or uppercase. Let's check. Is this an ASCII character? We are asking if this is an ASCII character. How did I get this? I use Alt D in Mac OS, or you use Option D in your PC. So we ask the system if Alt D is an ASCII character. Using the method called is ASCII. If we run this, says false. This is not an ASCII character. So we use, for instance, if I wanted to check for D, if I add the same question, say what is true, that this is what an ASCII character. Hope you understand this. Thank you for viewing. Multiply Python with a space by 3. How would you do that? You simply say Python multiply by 3. Remember there's a space here. If you run it now, have Python in 3 places. So whenever you want to multiply, so you can multiply string by integer, and you will duplicate it by the number you put in this place. Hope this is understood. Thank you for viewing. How would you check if a string begins with a specific substring? If you have this, how are you going to check if this string starts with Y or start with U or whatever? You simply do dot start with. Then you specify what you want to check if it starts with what? U. You say it's true, it starts with U. If you put the wrong value here, you have false. Hope this understood. Thank you for viewing.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
How would you check if a string ends with a specific substring? Something like this, I want to know what it ends with. If I want to know what it ends with, I will say ends with. I'm asking the system, ends with, and I tell the system what I'm looking at. I can say ends with question mark, say yes, it's true. Or put soon here, say it's true. But if you put only soon without this last character, see what it will tell you, false. So you must start from here to start putting whatever you want to put. Even to this place, it will tell you what it is true. Even though you copy everything, it will tell you what it is true. You can see because it's after this. As long as nothing is missing, as you are going like this. So when you want to check, you check from here, compare it with these values. Checking, comparing, until you get to the end. If you put a different T here now, it will tell you false. Hope this is understood. Thank you for viewing. Convert the integer 678 to a string. What is that? To convert any integer to string, you simply use str. If I apply this now, 678, you see it's now what? A string. So for instance, if I assign this to a variable, I say 678, can I say, okay, I want to say r is equals to strt. That is, I want to convert this to string, then assign it to r. Now, I want to check the type of data that is r now. You see, it's not a string. What would you do to get this from this? So if I take this now, this is the input. I want to have this output. With this, you can conclude that this is what? Use the partition method. To get this output, apply the partition method. Then I want to partition at yourself. If you run this, you have this output. So whenever you want to return a tuple of this nature, look at where you want to partition it. Then you can have this. If I had put it like this, you have it like this with spaces before and after. So it depends on what you want to achieve. Return the minimum and maximum characters from this string. Ability. Okay, let's check. Return the minimum and maximum character from ability. To do this, simply say min. Then you put what? Ability. That A. Remember, A is a minimum, Z is a maximum in alphabets. From minimum to maximum, we have A, B, C, D. So that is what? That is ascending order. So if you want to get the maximum, you simply say again ability. Okay, see Y. In this string, Y is the maximum. But don't look at it as, oh, it's because A is the first here. No, that's not the case. If I put, for instance, I say, okay, let me do another thing. Say, okay, mass, let's say good. You see, it's not O, because when you read A, B, C, D to Z, O come after D and G. If you want to get the minimum, for instance, of this, you see that the minimum is D. All of this is understood. Thank you for viewing. Check the following string and confirm which is all uppercase or all lowercase. Okay, let's check the first one. And if you want to do that, you use is upper. Is upper. It says true. If you use this lower now, to tell you that what is false. Let's check this one too. To ask the system, is this all upper or all lower? Is lower. False. If we run this, put upper here. Is upper. It's still false. That means this is neither upper nor lower. Let's run this. This dot is upper, for instance, says false. If we run this, I check if it's all lower, you say it's true. So to confirm that a string is all lower or it's all upper, you use either the is lower or is upper. Hope you understand this. Thank you for viewing. How do you check if a string is completely made of white space? To check this, for instance, this white space is space. You put a letter of any kind. It's false. Okay? Also remember that Python recognizes new line as white space. You see? And also remember that Python recognizes tab as new space. This real white space, new line, tab are all considered in Python as white spaces. I will use a space to verify if everything in a string are all what? White space. Hope this is clear. Thank you for viewing. How do you check if the characters in a string are alphanumeric? To know, you simply use what? Is rnum. That is, if I have this now, let me do this. I will put is alphanum. That is alphanumeric. I am asking the system. Say yes. Okay. I will copy this time, put back here, remove this, then check this. True, because this what? Alpha. If I put it here, I leave the numeric. See? See true. But if you put a different thing here like heart, for instance, if I put ash, this. So understand this, when you want to check if a string is made of alphanumerics, then you use is alpha, that is al num. Hope this is understood. Thank you for viewing. How do you check if the characters in a string are all alphabets? For instance, if I say hello, these are all alphabet, and if I want to confirm this, I will simply say is alpha. Are they all alphabets? Say true. Okay, what if I do something like this? This is lovely. This will give me false. Is alpha. Let's see first. False. Why? Because this space is not what? Alphabet. But if I remove the space now, I run it, say it's true. Hope this is understood. Thank you for viewing. How do you check if the characters in a string are all numeric? Is all numeric? Says true. What if I have done something like this? Let's put numbers as well. I add the system. Is numeric? Say false. So when all the numbers are all numeric, it will return true. If there is any miss with other characters, it will return false. You are given this, a list of strings to get ABC. How? That is ABC with hyphen. Because we are going to use hyphen to join them, as you can see, first of all, you have to analyze this. We see that all this were removed and this is put in between them. That means we need to join this with hyphen. We simply put this and put what we want to use to join them. Then we put join. You remember join in topo? Same thing here. Then we give the system the list of string A, B, C. If we run this now, we have exactly the same things. You are asked to split is coming to get E is coming. That means you are meant to split all this into these sub strings. How do we do it? Let's get this. I say this is the input. We need to split it by what? You split by the spaces because there is no any other thing given to us here to split by. We put this space, we split. See? It is coming. Assume this was hyphen, this was hyphen. We can simply put that hyphen there. Same. Or if I copy this now, I put something like at here, at here. If you want to split, you can split by two of them. It will go. But if there's only one heart here, and you want to do this, know that this one will not be splitted. This will still remain the same because it's not only this that is here, but including the art. You see? Hope you understand further how to use split now. You are given the string, John is running home, and you are asked to get the index of O in home, not the index of O in John. How? Okay, John is running home. That is the string. Okay? And we are asked to get the index of this. if you use this index, you say of O, you see, it's giving us this one. That's 0, 1. The question says we are looking for the index in home, not this. To do that, you have to jump this one. Start from somewhere here or somewhere here to search for the remaining one. So what I will do, I will simply say start from 3, hand the minus 1, because I say search from 3, that is 0, 1, 2, 3, to the end, because I know there's no any other 0 before the end. If I run this now, I have 17. That means the index of this is 17. Count the number of I in it is good to be in school. This is a string. We are asked to count I. Let's run it. 3, that is 1, 2, then 3. You can also search, for instance, for good if you are asked to do that. It's only 1. What if you want to check for 0? 5. Solution is 3. The number of i's in this string using the count method. What is casting in Python? Look at this. If I say v is equals to 12, or I say r is equals to 2.5, this is integer. This is a float. There are some time you want to specify the type of data you are passing onto a variable. The type of data you are passing onto v, or the type of data you are passing onto r. This is integer, and if I run this 2, if I say v, it say what? V is 12. So what type of data is v? It says an integer. Okay. Then if I say this is r, what is r? What type of data is in r? It says a float. Okay. I will copy these 2 now, put them back to this place. This time, tell the system that this is a float. Because if I leave it as it is, it will say what? It is what? An integer. I will tell the system that this is what? An integer. What I am doing now is called casting. Because I am casting this. I am forcing it to be what? A float. I am forcing this now to be what? An integer. That is to say, all the decimals will be removed. If I run this now, if I say v, you see, in this place, when I just put 12, when I put v, it shows just 12. Now, because I force this to always be a float, it say what is 12.0. If I put r now, if I enter, see, instead of 2.5, it's not 2. It's forcing it to be what? Integer. This is called casting. You are forcing the variable to always what? Receive this value as what? Integer. Now let me show you. So if I say type v, it say what? It's a float. If I also ask the system what type is r, it say what is. Look at this. You agree with me that this is already a string, this is an integer, this is a float. But I'm telling the system that I am casting them as strings. All of them are strings. Strings. You are forcing them. You are forcing them to be in string formats. This is called casting. If I run them, you see this result. If I ask the system what type of data is in what? In B. You see string. If I say type in C, strings. Type A, strings. You see? Hope this is understood. Thank you for viewing. What is the meaning of container in Python programming? How is it different from collection? Before we look at this, let us refresh our memory on the meaning of object in Python. Everything in Python is considered what? Object. If it's integer, we say it's an object. If it's a string, we say it's an object. If it's a list, we say it's an object. If it's a tuple, we say it's an object. Dictionary is an object. Even true is an object. Even false. Everything in Python is considered what? An object. Now, what is the meaning of container? As the name go, container. That means if you are a container, that means you contain something. There's something you are carrying. Okay? In Python, containers are any object. Remember, all these are objects. Any of these objects, for instance, that holds an arbitrary number of other objects. Whatever this object may be, I don't know. If you have other objects you are carrying, you can hold the object. We call you what? A container. I can also draw it like this. I say any object that can hold other object, that can carry other object, that object is called what? A container. How is it different from collection? Container and collection are the same. In Python, it is called container. In other programming languages like Java, this behavior is called what? Collection. Generally in computer science, container and collection are synonymous. Some people use them interchangeably. But in Python, the name given to this behavior, this ability, is called what? Container. What are the examples of a container? These are lists. You agree with me that if I say, for instance, n is equals to 2a 4 7. This is an object, this is an object, this is an object, this is an object. But n is holding this object. So we say n is a container. Okay? And this is a list. Because of the presence of this square bracket, this is a list. So list in Python is what? Example of what? Container. Another example is tuple. Another one is set. Another one is dictionary. We have just considered this one in the previous sessions. So list, tuple, dictionary, set, they're example of container because they have the ability to carry or to hold or contain other what? Object in Python. And in other programming language like Java, it is called what? Collection. Hope this is understood. Thank you for viewing. What is the meaning of iterable, iteration, and iterator? Remember, in Python, everything is what? Object. If there's an object that is a container that can return its member one after the other, that object is called what? Iterable. What am I saying? If I say A is equals to 1, 2, 3, 7, 10. If I want to loop through the object of this object, remember everything in Python is object. This is a container that contains all these objects, and all these objects are integer. And we call this a list because of this square bracket. Looping means I start from here and move to the next one, move to this, then move to this. This is what? Looping. If I loop here, this container return me 1. I move to the next one, it return 2. Move to the next one, return 3. Move to the next one, return 7. Move to the next one, return 10. Then stopped. This is what? An iterable object. That is list. The process of looping through is called what? Iteration. Okay? It's called what? Iteration. Then what is iterator? Iterator is another object that if I apply next function on it, it will give me this first one. If I click next again, return this, next return this, next return this, next return this. Let me demonstrate this. I'll show you. A is equals to, for instance, 1, 2, 3, 7, let's say 10. What type of object is this? It says a list. Okay. Can I loop through? How do I know if I can loop through? I can only loop through if it's what? An iterable object. How do I know if this is an iterable object? Let me say B is equals to A. No error. It means what? This is iteratable. Then what I will use to confirm this now is to put on this B, next. If I say next, for instance, B. Remember, I'm using Jupyter Notebook. If it was not Jupyter, I have to say print to print the next on this. Let me run this. If I run this now, I have 1. If I run this again, I have 2. If I run this again, I have 3. If I run this again, I have 7. If I run this again, I have 10. If I run this again, error. No more what? Object to return. Look at it. All these that you return 1, 2, 3, 7, 10. They are all coming from this place. Remember, I applied this next on B. B is what? A. Meaning, what I've just done here now is, I asked this guy, this function, iter, to pull this object. I put them here. Why? Because I want to use nest to return each of the object. So if an object is iterable, or let me say if a container is iterable, and you apply this on the container, wherever you will put this is called what? Iterator. Remember, A is not the iterator. What is the iterator? B is the iterator. I apply itr function on this container, which is iterable. Iterable in the sense that what? I can loop through. Once I apply this on this, whatever that is the result, it's like you carry all these ones now, you put them inside B, waiting for me to apply nest. Okay? But if I apply nest on A, it can't go. Let me show you. If I come to this place that say nest, I say, okay, let me put this one and I put A here now. If I put A here now, error. This is just a container. And it's iterable because I can apply for loop here. I will explain for loop later. To loop through these items, I need a for loop. That is moving from the first one to the next one, just like that. I can apply a for loop on this A. That make it what? Iterable. Okay? But if I want to apply this function next on A, it's not possible because A is not iterator. Okay? So an iterator is a collection of objects that hold multiple values. Okay? That also provide a mechanism to traverse through them. How do I mean? Remember this one, there's no mechanism to traverse through this one. The only mechanism to traverse through this guy is this nest. But this one will make it what? To be accessible. This one will make the object in A to be accessible by nest. So wherever you will put this one is called what? Iterator. Because you can iterate through them using nest. But this container is called what? Iteratable. The process of doing this, the process of iterating is called what? Iteration. You understand? Let me repeat again. I have a list of objects. Let's say A, B, C, D. Okay? I can loop through them. Because I can loop through this one, it's called what? Iterable. Then, I want a way that I can access this object directly using nest. But it's not possible now because K is not what? An iterator. To make K an iterator, I need to apply this iterator function. Iterator function on K. Once I apply this and I put the value of this in a container, let's say B, that means I'm preparing it now for forward processing. When I apply nest on this container, it will be giving me all this value one after the other. We say this particular one that is here, whatever this container is, that can allow me to access its value using nest is called what? Iterator. The process of doing all this is called what? Iteration. Hope this is understood. Thank you for viewing. Which of the following is not an iterable object? The first one, as I can see, is a list. Let's see. To confirm this, I will simply apply the iterable function to it. It's a list iterator. That means you can iterate through it. And to further confirm this, let me apply K equals to this. Then I will say next K. See, it's giving me all the value one after the other. The next will be 8, the next is 9. If I apply again, it will give me error because that is the end of 9 is the end of the object in this container. Okay, that is one. That means the first one is iterable. Let's check this one. This is a tuple. If I check the type, B. It's a tuple. So let's see if it's iterable or it's an iterator. You see? Tuple, iterator at this location. So if you also apply, let's say we want to apply this to H. If I say next to H, so the next thing we need to do, let's apply this to, let's put H here. and put the value of this to h. Then let's apply next to it. Next, so we are iterating through them now. If I click this one again, if I click it again, if I run again, error now. That means this, a tuple, is iterable. Let's see, this is set. What about set? Let's put set here now. You put a type. If you put type, it says set because of this curly bracket. Then let's see if it's an iterator or iterable. Set iterator at this. So now let's apply this to a variable. Let's say variable v equals to this. If I put next here now, it's giving me 2. See? So I'm iterating through all of them. That is the end of the values. Error now. And they are iteratable. That means you can move through them. You can loop through its values. You can loop through its value. You can loop through this one's values. This one is what? A dictionary. Let's run this now. This is a dictionary. Let's see. This is a dictionary. If I enter, if I say type, it says a dictionary. If I apply the iterators function, it gives me this. Then, if I apply next here now, let me apply this to, let me put this one to a variable. Then let me apply next to it now. See, I'm having the first one as what? M. You can see it's looping through what? The keys. Okay? If I click this one, the key of this one, though it's going through the keys, is what? Iterable. As long as I move from this state to the next state to the next state. Because once you have access to the key, you have access to the value. Next of this, next of this, next of this. That is all. Okay? So this two is what? Iterable. Okay? Now let's see this last one, which is what? As you can see, this is a string. We enter, we check type. Say it's a string. Now let's apply if it is iterable. Let's check if it's iterable. See, yes, it's string. It's an iterator. So we put the value of this to, let's say pp equals to this. Okay, let's run through pp. See, it's giving us the value. If you run here again, giving us each of the values. Each of the values. That's all. That's all. It means there is none of these that is not what? Iterable. So all of them are what? Iterable objects. Okay? If there was something like number, let's say y equals to this, for instance, this an integer. If we say, is it an iterator? It said error. It's not. Int object is not iterable. Okay? What if this was just a float? For instance, if I run this, float object is not iterable. What if I put through here, I run this, see, bool object is not iterable. You see? And so on and so forth. So you can see that there are some things that are iterable. There are some that are not what? Iterable. Hope this is understood. Thank you for viewing. Let's look at Python range. What is Python range? Python range is an inbuilt function that allows you to generate a series of numbers within a given range. The first thing you need to do is, what is the meaning of series of numbers? These are series, just with the increment of what? 1, and so on and so forth. You can have this type of series as well: 2, 4, 6, 8, 10, 12, and so on and so forth. These are series with the increment of 2. You can also have this type of series: 4, 3, 2, 1. Decrement of what? 1. These are series. There's consistencies in the numbers. You can easily detect that here is being increased by 1. Here, increased by 2. Here, decreased by 1. This function is inbuilt, And it allows you to do this without any restriction. For instance, if you are given a range and a value here, this is where it stops. What is the meaning of that? If I say a range 5, it means start from 0, get to what? 4. Don't reach what? 5. Because range start from 0 unless you define otherwise. So I can easily say 0, 1, 2, then 3 for this. What if you have this type of range? Range 10. It means start from 0, get to 9. Stop at 10. 0, 1, 2, 3, 4, 5, 6, 7, 8. Before what? Get to 9. If you have this type of range, let's say range 20. It means start from 0, get to what? 19. Then put all the numbers in between. Range 100, for instance, it means start from 0, get to 99. You put 1, 2, 3, 98 before 99. This is what? The meaning of stop. This stop means whatever you put here. If you have a range and only one number is put here, let's say 3, it means start from 0 till you get to 2. Don't put 3. Stop at 3. Okay? The next one is this type of range. If you are given this type of range, say range, for instance, I say range 2, 5. It means start from 2, don't get to 5. Stop at 5. Means 2, 3, 4. Remember, if one number is just here, assume I say range 5. By default, it starts what? At 0. You start from 0 and end at what? 4. Don't put what? 5. Because we did not define the start. Here we are defining the starting point. That's the meaning of the start stop. If I say, for instance, range 3 to 11, I mean start from 3, you reach here, don't get to 11. Then 10. Okay? Then we have this type of range. This type of range, that is to say, tell us the starting point. Let's say 1. Tell us where we should stop. Say stop at 5. What are the steps? As a step of 2. It means start from 1, add 2 to 1, you have 3. Add 2 to this, you have 5. Because we are meant not to reach here, these are the only 2 values that will be what? Given to us. This only these 2. Remember, start from here, but don't reach here. This is a stop. You don't measure 5. Begin to add 2. Let's check another one. Range, let's say 5, 20. Then we put 3. This one simply means start from 5, don't get to 20, but increment of 3. That is to say, start from 5, add 3 to this place, you have 8. Add 3 to this place, you have 11. Add 3, you have 14. Add 3, you have 17. Add 3 again, we have 20. But because 20 should not be mentioned, we stop at this point. Remember, we are adding what? 3, 3, 3. That is the meaning. Step of what? 3. What about something like this? Range, we say 0, 10, 2. Can you give me the answer? Very easy. Start from 0, continue to add 2. Now, I'm supposed to put 2, but you give me 10. I don't want to measure this. But if we have done something like this, say range 0, 11, then 2. That is to say 0, 2, 4, 6, 8, 10. If we add 2 to 10, we have 12. This is already more than that. We don't want to get here or above this value because we say stop. This will be what? For this. Hope this is understood. Let's move on. Okay? We are talking about range decrement here now. This is just introduction. Here, we have a number here, let's say 2. We are asked to stop at, let's say, -4. Then we say we are going to decrement by -1. You can do decrement. That means most of the time when you are doing decrement, what is here is always greater than what is here. For instance, this will give us this. The solution for this is You start from 2, remove -1. You have 1. Remove -1, you have 0. Remove -1, you have -1. Remove -1, you have -2. Remove -1, you have -3. If you remove -1 again, we have -4. But we don't want to get to this place because it's the stop point. What if you have something like this range? Let's say 20, 10, -3. This means we should decrement. That's why you see this minus here, this minus. This simply means 20. Remove 3, you have 17. Remove 3, you have 14. Remove 3, you have what? 11. If you remove 3 again, you have what? 8. We don't want to go below this. Then reverse. If I give you a range of say 5, you agree with me the value that will come out are 0, 1, 2, 3, 4. But if I say reverse range 5, that means we're going to have 4, 3, 2, 1, 0. Okay? When you want to reverse the result, you put this reverse function on range. Okay, let's continue. What about this particular one? Don't be confused. We are going to see all these things in our what? Instances. If you have a range and the top value is given to you, let's say 10, and there is index, let's say index 3. What is that? Here, you agree with me, it means 0, 1, 2, 3, 4, 5, 6, 7, 8, then 9. Don't get to 10. And index simply means this is index of what? 0, index 1, index 2, index 3. It means the system is asking us to print only 3. So this will return what? 3. Okay? What if you have range 10, index of, let's say 4, means it will give you this. Just the index of all mean the same thing. This one is telling us about what? The position that you want the system to print. Okay, what about this? We have a range, a value is given to us, let's say 5. It's telling us what? This is slash, that is slashing. Okay, if we put, say, 0 to 2, it means this is a starting point. Remember, don't measure this. That is why you see stop here. Don't measure this. It means, originally, this alone means 0, 1, 2, 3, 4. Then with this, it means index of what? 0, 1. Don't get to this place. So it will print only this for us. We have actually treated index where we are doing what? List. Now let's look at Python for loop. What is that? Whenever it comes to iterable object, you can use what is called for loop to iterate or to loop through the objects of that iterable. How do I mean? If I say, for instance, say I is equals to this list of A, B, C. I want to loop through without using ith function or the next function. I will say for anything. I say for value in I. Okay? What I'm doing is that I'm referring to each of these now in this place. This is the word iterable, which is I. Okay? Then I'll put a statement. What do I want to do with each of them? I can say, when you give me each of them, multiply each by 2. Once you multiply them, apply whatever you got. Let's say G is equals to whatever result you'll be getting. Can I say, okay, I want to print G. Let's run this. You see, what I've just done is this. I said for value in I means it will start with this one. That is the first one. It will multiply it by 2. So this one will come as a string. Multiply by 2 become double. Once it finishes with this one, it goes to the next one. That's why we said it is iterable. Go to the next one, multiply by 2, put it in G, print G, have this. Go to the next one, multiply by 2, and so on and so forth. Okay? Also, what I can do, without even multiplying, I can simply say, help me print the value. For instance, get me each of these. Then whatever value you have, just go ahead, what? I print it. That is, print it. See? The first one, iterate, print. Went for the second one, iterate, went for the third one. So once you get each of the value, you do it line by line, what you want to do. For instance, I can come here again, okay, the value you are having plus another string, say, let's say boy. I can say instead of doing this, simply go and print it for me. Go to this place, print this for me, print this for me. I can run this now. You see, a boy, B boy, C boy. How? When it gets here, put the value here, it had to this one, a boy. Came here again, put it here, B boy. Came here, put it here again, got this. So in summary, for loop is done as for, then you put the values in the iterable. The iterable is this I now, okay? In iterable. Put the iterable here. Then you put your what? Your statement here. Whatever statement you want to put. Can be one statement, it can be two statements, it can be many statements. Okay? This is how to use what? For loop. Find the range of the following numbers: 0, 1, 9, 10, 23, 100, and 1000. What it means is get the numbers which are from 0 to the given number. And you have to stop at this number. That means this number should not appear in your output. All this. Okay, first of all, let's see. Range 0. You say it's 0, you start from, but don't measure it. For I in this, if you want to print the result, you use this for loop. For I in this range, print I. If we run this, nothing is given to us because it is nothing. Okay? Now let's put here 1. If you run this now, you see, it means start from 0, but don't mention 1. This is the starting point. This is what? The stop. And if I put 1 here now, you see only 0 was printed because we started from 0, but you should not what? Include this one. You should not include 1. Now let's look at 9. For 9, start from 0, but does touch this. That means 0 to 8. And if you look at it, by putting 9 here now, we have what? From 0 to what? 8. Remember, this is the stop, okay? Now let's look at 10. 10, you agree, is from 0 to 9, because we are not going to what? Touch this. And if we put 10 here, you see, it starts from 0, ends at 9. Now let's look at 23. You also agree with me that it's from 0 to what? 22. It's telling me that this is the beginning, this is the what? Stop. And if I put 23 here, we have 222. See? 222. Okay, the next one is 100. Let's look at 100. That is from 0 to 99. Okay? And if you put this, I mean, this is the start, this is the stop. Don't get to 100. And if you put 100 here, you see it's from 0 to 99. See? 0 to 99. And also, if you look at this 1000, you see 0 to 999. That is 0, don't get to 1000. If you put 1000 here, we have this. Hope this is understood. Thank you for viewing. Find the following: range 3, 15, range 0, 10, range 10, 15, range -4, 4. Okay? This, for instance, is a start. Here is a stop. It means start from 3, but don't get to what? 15. If I run this as it is, we have the same thing. And if you want to print out this, simply say, for I in this, then you print I. You see? From 3 to what? 14. Start from this place, but don't get to this place. So let's look at 0, then look at 10. Before you see the result, you should already know what you are expecting. So we are expecting from 0 to 9. Okay? The next one is 10 to 15. That is, this one will give us from 10 to 14. So 10, start from 10, but don't get to 15. If I run this, we have 10 to 14. This last one says start from -4, but don't get to 4. That means from -4 to what? 3. So -4 to this. That is -4 to 3. Hope this is understood. Using range, start to stop. It says find the following: range 0, 23, and the rest. This is a start. This is a stop. This is the step. That is to say, for example, here you have 0 plus 3 plus 3 plus 3 and so on and so forth. Here, 4 plus 2, plus 2, plus 2. Continue down. The same thing here, minus 10, plus 5, you have minus 5, plus 5, you have 0, plus 5, you have what? 5. If you plus 5 again here, definitely you're going to have 10. And this 10 is not allowed to be among these outputs. Now let's see. If I say for I in this, just to see the output, let's see. For I in this, print I. Okay? Step of 3. We had it 3, 3, and you have 3 here now, becomes 21, and this is the stop. You can't jump over the stop. If you take this now, let's look at this now. For I in this, the same thing, you start from 4, begin to continue to add 2, add 2, add 2. When you get to this place now, if you add 2 now, you're going to get what? 20. And 20 is not allowed to be among what? The output, because it is a stop. Now let's come to this place, do the same thing. We print high. You see, the same thing the way we explained before. This is the beginning. When you had 5 here now, you're going to have what? Minus 5. That is this. If you had 5 here now, you're going to have what? 0. That is this. If you had 5 here now, you're going to have 5. That is this. If you had another 5, you're going to have what? 10. That is not allowed. To have this among what? The outputs. Hope this is understood. Thank you for viewing. Find the following. There is no difference between this and what we have been doing since. All we have to still do is to continue to add this one to this one until we get to this level. What I mean is, if I take this now, I say plus minus 1, it means 9, plus minus 1, it means 8. It will continue to decrease until we get to this location. That is, we are decrementing. Now let's see. If I take this for instance, say for I in this, print I. You see, it's decrementing by 1, 1, 1, 1, until you get to the number before the stop. Okay? Now let's continue. If you take this as well, it means the decrement will be by what? 3. If we do that for I in this, we print I. See, we have 15 minus 3, or plus minus 3, until we get to this. If you put minus 3 here again now, you have minus 15. And we don't want that to be among these outputs. Finally, let's look at this. For I in this, print I. You see, we have 100, you remove 10, just like that, until you get to this location. Remember, if you remove 10 from here now, you're going to have 0, and 0 must not be part of this output. Whenever you want to decrement, the value for the start is always greater than this value. In every decrement, this value must be greater than this value. The same thing with DC. 100 is what? Greater than 0. Hope this is understood. Thank you for viewing. What is the reverse of the following range? Okay, that is, if you find the range of each of these, what is the reverse? Remember, if you want to get this now range 4, you're going to have what? You're going to have 0, 1, 2, and 3. And if you want to reverse them, you must start from 3, 2, 1, then 0. And to reverse them means 3 first, followed by 2, 1, then 0. To get the reverse of this, just say for I in reversed, then you can print the output to see the result. See? Starting from 3, going backward. Let's check for 7. Let's check for 9. Let's check for 20. The purpose of this is just for you to be familiar with these things, because we are going to use a lot of them in this course. We want to know each of them bit by bit. Later, we're going to design applications. I believe you will not be confused. Hope you understand what we have just done. Thank you for viewing. Find the value at the index of 3 of the following. Okay, this is range 10. You agree with me, range 10 simply means 0, 1, 2, 3, 4, 5, 6, 7, 8, then 9. And the index is always starting from 0, right? That is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this index of 3 means here, 3 will be the value. Like this other one that is starting from 4 to 9, you start from here, 0, 1, 2, 3. So this is a value at index 3. Let's continue. Let's prove that. For I in this, print I. But the question says we want only the value at what? Index of 3. To prove it, simply say this, you put 3. Look at it, it's 3. If you look at this one now, you simply put this, the index at 3, you see, 7. What is the value at the index of -2 of the following? That is to say, this, for instance, will give us from 0, 1, 2, t, we get to what? 11. Before 11, we have 10. Before 10, we have 9. But we are not going to get to 12. The index of -2, it means start from the right-hand side, go towards left-hand side. Remember, the normal way of movement is to start from left-hand side towards what? The right-hand side. But this minus now means start from this side, go towards what? The left-hand side. And when you are moving from the right-hand side to the left-hand side, it's always from -1, not 0. We are coming from here, you start from 0, 1, 2. That's indices. But you are moving from the right-hand side, you start from -1, then -2. It means this is going to be what? 10. Let's see. If I ask the system now, what is range -2? It says it's 10. The same thing goes here. Start from 20 to 100, but I want the value at index of -2. Remember, it will end at 99. We have 98, we have 97. This is -1, this is -2, this is -3. There's continue to go down till 20. So without bit 2, this will be the value of what? Index of -2. Let's see if I copy this, drop here, look for it, -2, we have 98. So we need to understand these little things which will later help us in our career. All this understood, thank you for viewing. It says, what is the value at the last index of this range, this, and this? One thing you should know is that the last index of every range, of every set of numbers is always -1. That is the end. Second to the last is -2. Third to the last is -3. The first is 0, second is 1, third is 2, fourth is 3, because we are starting from 0. But when you are looking from the end towards the beginning, you start from -1, -2, -3. So the last index is always -1. With this, you can find the value in this location using, for instance, this -1. Let's see. If I take this, for instance, even before you get your result, you should know what you are expecting. I know, for instance, that if I start from 30, I will have 30. If I remove 3, I will have 27. If I remove 3, I will have 24. If I remove 3, I will have 21. If I remove another thing, I will jump this. I don't want that. Therefore, 21 will be the result. Let's see. The last index will be 21. So this is the last index, which is 21. The same thing for this. You start from -20 going towards -2. The major thing I want you to know here is how to get the result in your mind or in your head before you run this. Remember, we start from -20. I continue to add 4. If I add 4 here, I have -16. If I add 4 again, I have -12. If I add 4, I have -8. If I add 4, I have what? -4. If I add 4, we have 0. 0 will jump this. I don't want that. This is the last value. So if I run this now, I should have this. It's -4. Let's look at this. Without being told, put -1 to get the last value. It means you are starting from -2. You put 1, -1. You put 1, you have 0. You put 1, you have 1. If you put 1 again, you have 2. We don't want that. So the last value now will be, if you run this, you have 1. Hope you understand how the system is working behind the scene. Thank you for viewing. /return range 112 and range 135 by 1 to 4 and 0 to -2. What is this? Remember, this is all about knowing the answer before running the program. Range 10 simply means from 0 to 9. If you are asked to get this class, it means you start from this index of 0, start from here, Then you stop at 3 before this value, which is this. That means 1, 2, 3. For this guy, we have to start from this end now. This is what? -1, -2. Okay? Then that means start from 0 until you get to this place. And remember, you don't include this last one. Because we shouldn't include this guy, it will be from what? 0 to 7. Let's see. If I run this now, for instance, I put 1 and 4. See what I have? It's telling me that this is the meaning of this. This one is the meaning of this. So that means if I want to actually get this, I should do for I in range 1, 4. Print I. See? 1 to 3. Let's see the meaning of -2. That means 0 to -2. What is that? It means from 0 to 8. And if you run this, you agree with me, we are going to end at what? 7. For I in this, print I. See? 0 to 7. As you see what I showed you, you agree with me, I told you, from 0 to 7. Because what is at -2, we don't include it. And for the first one, I told you it's 1, 2, 3. Hope you understand how we got this. Let's move to the next one, which is range 1 to 12. Remember, here, by default, start from 0. But now, this is giving us what? Where we should start from. You follow the same process. 1 and 4. Okay? If you run this, or even before you run this, you know what you will get. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. He said we should start from 1. Remember, index means 0, 1. Start from this one, you get to 4. 2, 3, 4. That means we are going to stop at 3. Remember, we don't reach here. This is a stop. We don't reach this position where 4 is. We start from 1. We end at the number before 4, which is 2, 3, 4. If we run this now, we have this. I will agree with me that this one means 2 to 4. Don't touch this. And if we want to print to confirm, say for I in this, then we print. See? 2 to 4. If we copy this, for instance, let's just get this first. Let's put it here. Now it's 0 to -2. Okay? What is the meaning of this? Start from 1, we get to 11. It says start from 0, but don't reach -2. What is -2? That's -1, -2. Don't reach here. That means from here to here, from 0 to 9, which is -3. The value before -2. Remember, in mathematics, we have 0 before we have -1, before we have -2. Because if you are moving from this side to this side, it's according to what? The ascending value. This is ascending to this, ascending to this. The same thing goes at what? This is ascending to this, ascending to this. So this -2 is bigger than -3. Let's run this to see if we are going to have 1 to 9. If we run this first, we should be expecting, see? Definitely you agree with me that this one will give us what? 1 to 9. See? 1, 2, 3, 4, 5, 6, 7, 8, 9. Finally, let's look at this one with step of 5. With step of 5. If we run this with 1, 4, you agree with me that this originally will produce 1 plus 5, we have 6, plus 5, we have 11, plus 5, we have 16, plus 5, we have 21, plus 5, we have 26, plus 5, we have what? 31. Because it's above this, we can put. This is all. So I need to remove that comma. Now it says start from 1. This is 0, this is 1. 2, 3, 4, 5. Start from 1, but don't get to 4. It means we are going to get this one for this first one. Okay? But for this -2, remember this is -1, this is -2. That means we are going to end at -3. Start from beginning, that is 1 to this place. 1, 2, same 16. For for the second one. 1 to 16. The first one is what? 6 to 16. The second one is what? 1 to 16. Let's confirm. If I run this now, have this as a summary or the meaning of this. Then I run this using the for loop for I in this, print I. See? 6, level 16. Okay, this other one going to end at where? 0, 2, minus 2. Okay? We run this. It said this is the meaning of this. This is the meaning. Okay, let's see. For I in this, let's print.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
Slash the following by 0 to 2. The first thing you need to do is to get the values that are all here. That is starting from 3, be increasing by 2 until you get to what? You get to the value before 10. That is 5, 7, 9. He said what? If you start from 0 here now, to slash means start from 0. That is start from here, get to minus 2. This is minus 1, this minus 2. So you are not meant to touch this minus 2. That means these are the remaining one. 3 are 5. Let's look at that. If I take this now, first of all, I need to know what this one is. If I enter, gave you the same thing. But if we put this, I put minus 2, we have this. For I in this, print I. See? 3 are 5, which is the same thing with our analysis. 3 are 5. Now let's look at this. For this, we start from minus 10, continue to add 2, have minus 8, have minus 6, have minus 4, have minus 2. We add 2 here, we have 0, stop. Then the classes say you start from 0 to minus 2. That is minus 1, minus 2. That means the remaining one are these ones. Minus 10 to minus 4. Let's see. If we pick this, we put here. Then we take this, we put here. We run. So this is the one we're going to target now. We're going to say for I in this, we say what? Print I. You see? From minus 10 to minus 4. And if you look at what we just analyzed, you see? From minus 10 to minus 4. The purpose is just for you to understand how the system come about this value. So whenever you are given anything, first of all, analyze this, apply this slashing. You can get the output before you run it. It means you understand this range and slash it very well. Hope you enjoyed this class. Thank you for joining. You are asked to print the following. How would you do it? We can use for loop to achieve this. What I will do, I will type it out, then I will explain. Look at this. This will achieve this result. But how? For the for loop, concentrate here first. I said what? I in range this. What is the meaning of this? This range is n, that is 7. Okay? That is 5, 6. That's what this one can produce. I'm looking at only this range now. Okay? 5 and 6. Remember, end is 7. It cannot get to the end. Good. Why this one? For each I, when this line calls this I, 5 will be here. That means it will be 2 to 5 plus 2. That is 2 to 7. So what this one will print, it will start from 2 and end in 6. So what is going on is that this one will work. When it works, the first number it will get, it will be 5. When this works, the first number that will come from here is 5. Then we go further, we say j in range 2, I plus 2. That means the 5 should be put here, plus 2, make it 7. That means 2 to 6. Remember, it will not get to 7. We have this. The second one that we provide for us is 6. If we put this here, we have 6 plus 2, which is 8. That means we start from 2, our head is 7. Okay, good. Let's see. As you can see, we have the exact output. Okay, but if you wanted space between these, just tell the system I want space. See, if you want plenty space or plenty of spaces, you can do like this. Okay. If you remove this, you see what we're having? If you remove this, everything will be on the same line. To avoid that, you can say, okay, I don't want the full stop, for instance. If you put another thing like this, you have this. It's talking about the end before the next line. Hope this is understood. Thank you for viewing. Print the following pattern. That is 3 ohms. In physics, we call this ohms. And to have this in your keyboard, simply use Alt-Z or Option-Z. Okay? Now, how can you print this? There are 3 numbers. Since there are 3, I will simply say for I in range 1 to how many? 4. Because there are 3. So that's 1, 2, 3. It will not get to 4. I will say print ohms. Print ohms. That is Alt-Z or Option-Z. Look at the way it comes out. Because I did not indicate end here. I must put end to have it like this. And if I want space between them, I have this. Same print in the same row with this spacing. Okay, this is the pattern. One thing I want you to learn here, I want you to understand here is that when you add the system to print after looping, it is not necessarily that it must print 1, 2, 3 as you expect. It's still looking at this place. When this loop through this, the first one was 1. It's supposed to put 1 here, right? I would have said print I. We have this. But when it came here, I said whenever you reach print, always print ohms. That is ohms. Ohms. I can say print whatever. When you loop through this and you want to print, instead of printing this value, print this. When you loop again, print it again. When you loop again, print it again. That's what the system is saying. Okay? Print the following pattern. This. So how do you do this? We have 3 rows. That means the loop need to go 3 times. Okay? For I in range 1 to 4. Remember, this 1 to 4 will give me how many? 3 digits. That's 1, 2, and 3. Those are the rows. The first row, second row, and third row. Then, for the printing, I will say for J in range 1 to I plus 3. Why 3? Because if the first one comes, the first thing that is coming is 1. When the 1 is put here, it becomes 4. From 1, 2, 3. It will not get to 4. Understand what I'm saying? What I'm saying is this. If this one loop here now, it will bring 1 out. The 1 will be given to this guy to become what? Here will become 4. So when it's working here now, what it will provide is 1, 2, 3. Remember, it will not get to the end. So that means 3 numbers will be what? Printed. Okay? Print J. But if I print like this now, everything will be on the same line. You can see everything is on the same line. So I have to tell the system that after you finish printing for 1 row, give me the next line. The next line simply means this. That is to say, once you finish printing this row, then print nothing. If I put space here now, that means there will be space between the rows, which I don't want. So if I do it like this now, you have this. But remember, I don't want to print J. I just want each pretty should print ohms. And to get ohms, I simply say Alt-Z. Understand? If I actually want space between the ohms, I will print like this. And if I want space between the rows, I will put new line. Okay? But putting this alone means go to the next row. That is the meaning of this. And if I want spaces, I can put new line as many as I want. Can see? But we don't want that. We just want a new line. If we don't want this, we just want this. Hope you understand this. It depends on the number of rows. 1, 2, 3. If I put 5 here now, that means the number of rows will be 4. See? 4 rows. That means I'm asking this guy to go 4 times. If I put 10 here now, it will go, see? Hope you understand the reason why we put 3 here, 4 here. And the reason why we put 4 here. This one is the number of rows, that is 3 rows. Why here will give us what? The number of items in a row, starting from 1, 2, 3, or whatever. It depends on what this guy is provided to you. Hope this understood. Thank you for viewing. We can simply do this using the for loop from 1 to 5. That means we're going to put 6 here. We simply say print. You understand this? Very simple. For I in range 1 to 6, because we are asked to do for 5. So you see range, it will get to this last number. And we are asked to find the area of the square. So the corresponding area of square is this. Square is what? Any of the side raised to power 2. And as you can see, each of them raised to power 2 using this place, we give out the corresponding area of the square. Hope this understood. Thank you for viewing. You are required to print the following. This and this. What would you do? The first thing you need to do is to look at the pattern. We have from -5 to 5. That is to say, I have a range of 5 to 6. And this 5 is not just 5, it's -5. That is to say, I start from -5, I have -4, -3, -2, -1, till you get to this. Because this, you don't touch this one. Okay, that means I have to say 4 are in this. So what should I do now? I am meant to print I. But if I print I, it's going to be vertical. See? So for me to make it to be on the same line, I put end, then I put this. If I want spacey, I put what? A space here. The next one is to print this. And from my observation, if I put 2 here now, I have the same thing. Okay? What is the purpose of if statement? Explain and give examples of its usage. If statement. What is the purpose? The number one purpose of if statement is if you want to check the existence of an object. To check what? The existence of an object. 2, to compare 2 objects. These are the main purpose of if statement. Now let me explain further with instances. As it says, we should give examples of its usage. If I say A is equals to 2 and B is equals to 4, these are 2 variables with 2 values. And this is an object, this is an object. If I want to check the existence of A, what will I do? I will say if A, this is very important, the column. If expression followed by what? A statement. What statement? Print whatever you want to print. I can say Python is good. You see, I tell the system, if A exists, you print this. If I say if C now, because there's no C, it's giving us what? Error. C is not defined. If A, I can say print B. Whatever you want to do on this line at the statement level, you can do it. But the first thing you need to do is to ask a question to the system. Does A exist? If actually it exists, help me do something. Do this for me. I can see if A exists, help me print this. I can put this like this. If it actually exists, help me multiply the following. Okay? What about comparison? I can say if A is less than B, what do you want it to do? Print A, B. You see? It is because A is what? Less than B. That's why it printed this for me. What if I say if A is greater than B? Because there is nothing like this. This is not true. Then this was not executed. Because A is not greater than B. So this is what comparison. Remember I said to check the existence of an object or to compare objects. What if I ask the system if A or B? If A exists or B exists, do something for me. What should I do? I can say print that is true. If I say if A exists, C exists too, or if A exists or C, see, say that is true. Why? Because or work with either one of them is true. I can put here now B or C. It's still true. But if I put and here now, for instance, say if A and C exists, both of them will be true before we can print this. Let's see. See? C is not defined. But if I put A and R, because I know B and A, they are both defined, then it will print. You see? This is checking what the existence of B and the existence of A. What if I do something like this? Y is equals to, this is lovely. I can add the system, this in Y. It says true. Now what I will do now, I will say if this, remember it's true, right? Okay, if this, print that is true. If I put another S here now, you see what will happen? This was not executed because this doesn't exist in Y. What if I do something like this? Let me include, say, if one in this list, what should I do? Print yes, of course. But if I put something like 10 now, and 10 is not here, see what will happen now? This was not what executed because 10 is not here. So what you should also know is that this is what a tab. That is how many spaces? 4 spaces. Look at it. 1, 2, 3, 4. See this place? 1, 2, 3, 4. You know that for this to work, you have to make this place what? 4. 4 what? 4 white spaces. Another thing I want to point out is, let me come back to this place. Let me just put 2 cells here. If I want to run, say, if A is greater than, or let's say A is less than B, I say print that is correct. I can go further to say print you are good. I can go further to say print this is the end. I can run all this. Remember, these guys are working under this place. Okay? If this was wrong now, you see what is going on now? Nothing was printed because they are all working under this expression. Unless this expression is correct, this guy will not be executed. Now let me go down. If I come to this place and say print any log, for instance, say any log, although this is wrong, this guy is not working for this guy. This is not working under this place. It's just what on its own. It's not part of this statement. Just because of what? This what? Indentation. If I enter, you see, any log, although this is not correct, the system still went ahead and print this because this one does not depend on this. What should depend this is these white spaces. For instance, I can take this for instance, I put it here. See what will happen now? Say what? Print this is end. Unexpected indent. Why? Because you should finish with this guy before you bring this one in. Okay? If this is correct, for instance, if this is less than this, definitely all this will be executed. Still, this will still be executed because this guy is on his own. He doesn't know what is going on here. It's not part of this arrangement or part of this mission. Let me use that word. If I run this now, you see, these were all executed because this is correct. This is also what? Printed because it's on its own. It works normal, the way it will work where there is nothing before it or after it, just like this. Hope this is understood. Thank you for viewing. What is nested if statement and how does it work? Okay, if I say S is equals to 1, D is equals to 2, F is equals to 3, then enter. I can say if S is less than D, print whatever you want to print. Print yes. I can go further, indent further to say if D is less than F, print yes. Okay, let's say yes 1, yes 2. Okay, what have I done? Depends on this. And this one too depends on this. You can see 2 of them depends on this directly. Why this depends on this directly. Indirectly, this depends on this. Why we say they are nested? They are nested because this one must work first before this one works. Okay? If this statement doesn't work, this will not work. They are nested to each other. It's like staircase. One must exist before the next one exist. You can continue to nest them together. You can also nest more. If f is greater than s, print yes, 3. See, they were operated. Assume that I put, for instance, here now I put greater than, which is not true because d is not greater than f. If I run this, see what will happen. The system sees this, it ends here. Because this is not correct, it will stop here. Although this is correct, f is actually greater than s, but it will work because what it is depending on, this guy is nested to this. Because this failed, this couldn't work. So they are nested all together. This one succeeds for you to succeed. You must succeed for this guy to succeed. Because this guy failed, this was not ever executed. Hope you understand how it works. Okay? And what is nested if statement now. You can do some other thing, you want to do other things. I can come here now to say, okay, if actually this is this, d multiplied by f. Okay? I say, let me say k is equals to d multiplied by f. I say print k. Can do that. Okay, saying that d is less than f. I can do something like this. See? First of all, this was executed. We went further to check this. Correct? Yes. Multiply them together. What's multiply? Print k, where the result, the output of this is stored, before you go for the next one. Assume I change this to less than. The last one will not be executed because this is not correct. This is called what? Nested if statement. What is the purpose of s with if? S with if. Let's see. If I say f is equals to 10, g is equals to 12. If I say if f 5, print that is true. That is, if f, which is 10, is greater than this, print this. Okay? Now, I will copy this. What if I say this is less than 5? Because it's not true, it ends there. But what if I wanted to continue something like, if f is less than g, what should I do? Print 10 is less than 12. Look at this. Because this is not true, this couldn't work. Remember, this is nested to this. Unless this is true, all this one will not go. Okay. What if I want to continue testing? I want to continue checking. I don't want the failure of this guy to stop the success of this guy. What I will do now, I will simply put ends. But this ends must be benent, that below, directly below this if. Ends. Okay, I do this. Let's see now. Because of this ends now, this guy succeeded. Remember, before now, we had this, nothing happened. Now we have done this happened. Because this enable if, or whatever, this extended the capability of this program. What would have failed here succeeded. What it simply says, if these guys failed, do this one for me. If you can't go to school, hence, go and learn a trade. Okay? Hence mean go the other way around. If this road is blocked, the other road should be opened. Okay? This one is creating alternative way for this program to come to an end. That is the purpose of ends with it. It's like extending the capability of this objective, which would have failed here. If this is wrong or if this is false, we want a situation whereby even though this is false, the next one should still continue. I can even drop this one, print this. If f is less than 5, say that is true, whatever. Hence, print how can f be less than 5. See, this is wrong. It's printing this for me. This couldn't be executed, but this continued the program. What is the purpose of if with if and else? You already know this, you know this. So what is the purpose of else if? This is the short for else if. The purpose of this is to give you opportunity to do several alternatives. Several what? Alternatives. If doesn't work, I want to try more and more and more and more of whatever you are doing. You can be using this else if several times before you come to an end with these ends. Let me write a program, then I come back, I explain to you. Okay, look at this. I established this first name and I put Peter. This is an instance of somebody or a user of your website. You ask for the username and you put Peter, or you already have Peter here. You start testing against this first name. Who should this first name be? I already have pre-existing names you have put in the system. What you are expecting is either Andrew, Kate, David, Peter, Eric, or Anthony. That's what you are expecting. As somebody put Peter, you start comparing with all these available names you have already pre-programmed to compare with what? With this particular one, which you have assigned to first name. So the first thing you did is I say, if first name is equals to Andrew, you print Andrew. This is the first thing. What if it failed? To give several alternatives, because S cannot do this work, S cannot do this work, S cannot do this work. And using if, it's like they are disjointed what? Program. If I put if here now, that if is separate and it's not connected to this. Okay, let me first of all run this. See Peter, because Peter was here. If I put Peter's here now, because this is not Peter's, it will now print this last one. Let me show you again. If I put Peter's here now, here is not Peter's. See what will happen now? This last one will be printed. That means the system tried everything here and none was successful. Then it says ends. In case you try all this and you are not successful, print this last one. Why? Because this ends is seen. I will allow everybody to try. In case you try, you are not successful, come and print this. But this is not why we are here. We are looking for what? The purpose of this ends if. Ends if will give you time or opportunity to try different alternative of what you are testing. Different alternative. Assume I left it for if for instance. Say, I want if to do this thing. Okay, only if. Then I remove this S here. Let's see, be Peter. Let me run. You say, hi, Peter. After this so much try, you need to tell me who you are. But what you should know is that this program now ends here. This one ends here. They are not the same. All this one are not the same. Assume now, okay, I put Peter's here. That means none of them will be true. Okay. It will still print this one. What happens is that this is working directly with what? With each of these differently. Like this one now is directly attached to this. What I'm saying is all these are not continuation of this program. All these are not what? Continuation of what? Of this program. This one is on its own. This one is on its own. This one is on its own. But if you put ensif, it means there's a flow. This one, after you try this, go for the next one, go for the next one, go for the next one, until you get to this last one. So as if is giving you chance or opportunity to have different alternative till referring to this particular one. There's a flow now. There's a continuity. If you case you try this, it doesn't work. Okay, why not try this? Why not try this? Why not try this? Until you get to the last one. But if you put if, they are what? Disjointed. Each specie or each if is on its own. Each if is separately connected to what? To this last ends. Let me remove this as C. You see nothing is going on here now. Each of them are disjointed. If I put ensif, then I remove this T, remove this T, you see what will happen now? If I run this, error. Why? Because the system saw this first. This cannot be first in if statement. If must be there, all this will now be connected to what? If. But if I remove this one now, I remove this, I remove this, I remove this, I remove this, I remove this. You will see what will happen now. There will not be error anymore. See? It's correct now because each of these if, they are on their own. They are separate. These are all separate. Separated from this one, they are separated from each other. They are separated from one another. Okay? Because when this one starts, it ends here. It starts, it ends here. But if you are using ends if, It means they are relying on this specif. This specif will start the whole process. In case you don't succeed, okay, why not let me try this? That is the meaning of that. In case you don't succeed, why not let me try something else? Let me try something else. Let me try something else. Let me try something else. Until you now get to the last one. Okay? And what you should know is that once you open the floor with if for else if, it is not necessary that you put this. It's not a must. There will not be any error. See? If I run this, there is no error. Even though if this is not correct, let me put E here to make it not correct. No error. But if you don't put if at all, this if, to open the floor for else if, there will be error. Invalid syntax. Okay? If is to open the floor, else if is to alternate, to check for different alternatives. And if it doesn't succeed, you can still leave it like that. But there are some time you need to close this in case there is no success. You have tried, and there is nothing you could do. Finalize the whole thing with ends. Hope this is understood. Thank you for doing. Is there any other way to arrange if statement aside what we've learned so far? This is what we know, that if you want to do if, you say if, then you put this here down. But there's something we call one-line if statement. That is to say, instead of you to put this down here, you put the if statement, let me just drop this down on the same line like this. Okay? No error. It means what is allowed. You can put it on the same line. Even the else if, I can put everything what on the same line. Okay, let me do that. I come back. This one, same line, same line, same line, same line. Even the ends can be on the same line. You can see everything on the same line. If I run this now, you see we are still having IPython, because that is the only correct option. Even this place, I can put print IPython, then I put a semicolon. I say, you are great. Let me run it now. You see, IPython, you are great. The same line that is correct will be printed. Okay. If I want to put more, I can see continue. You are great and you are good. And you are good. If I run this now, you see, IPython, you are great, you are good. So we call this one what? One line if statement. You can put it on the same line. Even this one, you can put whatever you want to put. Just the same way I did this, you can do for the other ones. You can do 1, you can do 2, you can do 3, you can do 4. You can do like this. You see, they are correct. So what you should know here is that aside arranging them vertically, you can arrange them horizontally. Hope this is understood. Thank you for viewing. What is Python ternary operator? It is another way of expressing conditional state. The syntax is like this. You put an expression, let's say 1. Then you say if. Then you put the conditional statement or conditional expression. You use else, then last expression. Okay? Let me comment this out. This is a special, say Eric. That is this one. Then if the conditional statement. This is the if. This is the what? The expression. The ends. Another person. What am I saying? If balance is greater than 1,000, definitely the person is Eric. Otherwise, this person is another person. So to do that, I have to declare what is balance. Let's say balance is equals to, let's say 400. Now you see that balance is less than 400. That means this will be true. This will not go through. Let's see. See another person. Look at it. If this is true, this will be the output. And if this is false, this will be the output. This side and this side are opposite. For this guy, whatever you are doing here is true. This left hand side will be here, will be the output. If what you are doing here is false, this will be the output. So if I change this one to 1,400 now, I run it again. See now, balance is now more than 1,000. Therefore, Eric will be the output. This is called what? Python ternary operator. I explain again. If you run this and it is true, this will be the output, whatever that is at the left hand side. If you run this and this is false, whatever that is here will be what? The output. Okay, let's do more. Let me say, for instance, A in this. Say A, B, C. You agree with me that A is actually here, right? If this is true, what do you want to be on the left hand side? What I want here is that is true. Okay? If it is not true, ends. I put whatever I want to put here. That is false. I run. See? Because A is actually here, this will be the solution. If it was otherwise, for instance, put F here, which is not here, this will be what? The output. Whatever you want to be the output, if this is correct, put it here. Otherwise, put the opposite here. Let me show you another one. If I say, for instance, T is equals to 100, I can do something like print. What are you printing? Remember, it's left and right. Let's say, for instance, if not 100, that is what we want. If not 100. If not 100, what do you want to be here? What I want to be on the left hand side is you are not 100. What I want to be on the left hand side, I will say else you are 100. Remember, whatever I do here, if it is true, give me this. Now let's see, if not 100, this is actually 100. If not 100, give me this. Otherwise, this. Let's run. See, you are 100 because it's actually 100. If I say if 100 now, that means this one will be true. If you find that this is 100, it will give this one. You are not 100. I know it is not well typed. That's what it's saying. Remember, I should change the narration now, but I don't want to change the narration. See? It's not about what to narrate, what to put here. I can put anything here I want to put. I can put like this, for instance. Here I put, let's say, number this time. If this is true, this will come out. If this is not true, this will come out. Let's run again. You see? This is coming out because it is true. If I say not now, for instance, that means opposite. There, this one will be true because actually this is 100. You see? What if I do something like this? Okay, amount is equals to 400. Okay, I say D is equals to, if amount is greater than 300, I will say, give me the amount. Okay, on the right hand side, I say that is not true. You see, if I run D now, that means if amount more than 300, I say you print amount. It means when you find that this amount, which is 400, is more than 300, it places this at D, and the amount it placed here is 400. If, for instance, it was otherwise, that amount is no more than this, let's say amount is 100. Let me run this again. Definitely, this will be the solution now, which will be placed at D, and when you run D, you have this. Let's do that. If I run D now, I have this. This is called what? Python ternary operator. It is the same thing with what we have been doing. It's just that the way of expressing it is different. This is what I want if this is true. Otherwise, give me this. Hope this is understood. Thank you for viewing. Give M equals to 10, N equals to 100. Put this expression, this, to the normal if statement. This is given to us. And also N is given to be what? 100. So this is also given to us. And it says if M is greater than N. If M is greater than N, which is not true. If it's not true, this will be assigned to H. If it were true, okay now. So let me check H first. Let me see the value of H. H is 200 because it's not true. We are asked to express this in the normal if statement. How do you do that? That is to say, if, that is this place, let me just copy so that you understand better. If this is true, what should you do? Say H is equals to, if it's true, 100. Okay? But if it's not true, which is ends, say H is equals to what? The opposite, which is what? 200. You understand? Okay. If we run this now, we have the same thing. If I say H now, we have this. change this age to 300 so that I will not think that I'm talking about this same 200. Let me just change it to 300. Let's assume that this 300 is here now. Assume that 300 is here now. If I run this, the same thing. Let me run it now. If I run this now, this is 300. So this is the same thing with this. According to this challenge, we should move this to this normal if statement. Just for you to understand this and the same. It all depends on your style. Hope this is understood. Thank you for viewing. Let's look at more explanation on conditional expression. When I say conditional expression, I mean ternary operator. For instance, I can do something like this. For instance, say A is equals to 40. Okay? I can say if A is greater than 30, what should happen? What should happen is that 20 plus A. That means I'll be having what? 60. Okay? What should I do with it? Assign it to R. Okay? What if this is not true? I will say hence A minus 20. If I run this now, if I check R, I have 60 because this is true. He added 20 to 40 to give me 60. But if this was, let's say 10, and I run it, that means this side will be true now because 10 is not greater than 30. It means the system will say 10 minus 20. I should be expecting minus 10. So if I run this, I have minus 10. What if I want R to depend on everything here? For instance, I put this here now. I know actually I had minus 10 from here. There's no error. There's no error. I can have something here, for instance. Put 300 here plus 200. Or let me say put 30 here plus 20. What am I doing? This will produce minus 10. Add this and this to it. If I run again, you see I'm having 40. Minus 10 plus this will give you 40. You can do another thing like plus 400 as you want. What if I just do something like this? That's okay. 100. If true, ends, give this. Okay, look at this. I say if true, give me this. Otherwise, give me this. The next thing you should ask me, what is the meaning of true? True is true. That is, it's true. This will go. Okay, let's see this. What is it saying? We have defined name to be James. Remember, the major T is here. Here. I say if name is Peter, what should you do? You take this. But what about right hand side? Continue with the next one. If this is not correct, continue with the next one. If it's not correct, continue with the next one. This is called chain conditional expression. Chained conditional expression. Okay? Because they are all chained together. If this is not correct, then finally just put in. Or say, I don't know. Something like this. Because this is here now, I can simply put because of the presence of this, I can put this. Or I go back, I put this, then I escape this. This means recognize this. I can run this now, stay. But now let me put double S here to make sure that James is not the solution. If I put S here now, I have what? I don't know, which is from here. Because none was what? Correct. But if I remove this S here now to make sure that James are James correct, then if I run this now, if I put S now, I have James. This is called what again? Chain conditional expression. I believe with this, you should be able to handle Python ternary operator. If I want to type line of input from the keyboard, what should I do? You have a keyboard and you want to type in something like 24 and you want the system to prompt you. All you need to do is to use the input function. Then the system will prompt you to give it what you want to type. So let's see. If for instance I say D is equals to input, I enter. See, the system is asking me now, what value do you want to store at D? That's what it's asking me. It's giving me a prompt here, a place to type in what I want to type in. Okay, assume I want to say hello. If I enter now, if I click enter, the system will read them. I return them as what? A string. I enter now. Now let me check D. See, this now what? Hello. If I say what is the type of data here now? Hello, you say what? It's a string. This time I want to put something at, let's say V. It's asking me, I put 40. Then I say enter. Let me check V. The value of V now is 40. What type of data is this? If I say type V, you see string. So whatever you type in here, whenever the system prompts you to enter your line of input, is going to come as what? A string. But if you desire to convert what the system returned, you can convert as you like, either to integer, to float, or to complex numbers. The next thing I want to show you now is what if you want to instruct the user or want to do. For instance, I say y is equals to input. I want to tell the user to give me any number. I say give me any number. You see what we have here now? Also I enter, see? It's prompting the person, give me any number. So I want to show you that here you can type whatever you want to type, as long as it's with this single quote or double quote. Then the system will still prompt you because of this input. But this one is an option to use to instruct a user on what to do in case he or she doesn't know what to do. For instance now, I can give a number, say a number, enter. But that doesn't mean that this will be part of the input. No, it's only this that will be stored here. So if I put y here now, we have only this. So the thing we have learned is, in case you want input from the keyboard, use what? Input. And what is going to be returned is going to return as what? As a string, irrespective of what to type in. And also, you can give instruction to the user. You can type it in this format or any format. For instance now, let me say y2, then whatever. If I enter, you see, whatever. It's giving not exactly this. Although what we are seeing is rough because of this. And there is no spacing between this. Or because I did not provide that space here. If I wanted a space, let me say y3, I should give that space here. If I enter, I put whatever now, you see, the space is here. But this is what will be stored at what? At y3. It gives me this. If I say, what type of data is this? We tell me that y3 is a string. Okay? But what if I want to store something here? What I want to store here is, let's say y4. It's an integer. I can simply take this, wrap it, and I put it what? Int. Once I enter this, the system prompts me to do this. I enter. If I put y4 now, she's giving me this. If I say, what type of data is y4? You say y4 is what? It's an integer. Or because this one accepted input, but why it accept the input? Before it stored the value here, I quickly what? Converted it to integer. And if you wanted to convert to float, you can do the same thing. With complex, you can do the same thing. Whatever you want to convert to, you can put it before this. Okay? So it means that if I want to do something like this, I say r is equals to input, enter any name, for instance. Let's say enter any number. I enter, so let's say 23. So r now is what? 23. Okay. What if I want to add r plus, for instance, let's say 20, which would be what? 43. See what will happen now? The error it will return. See, can only concatenate string, not integer to string. See, this is a string. This is integer. Why? Because this input, whatever is returning, is going to come as what? A string. So it was your duty to convert first before you do this. What I will do now, we wrap this integer. Let me put R2 here. So I can put 20, then R2 plus, say 23 now, is giving me 43. All because this guy, 20, he returned, is in the same format with this 23. This 23 is integer. Whatever that is here is also integer because I converted what was what? Returned. And if you check the type of data in R2 to tell you what, it's an integer, all because you converted. Hope this is understood. Thank you for viewing. Write a program to prompt the user for an input and reverse it. Write a program to prompt a user for an input and reverse it. Okay? To prompt the user for an input, I can say n is equals to input. I will tell the user to what? Enter any, whatever the user enter, I will print it like n. But I need to reverse it. To reverse a string, we do this -1. We have done this before now. This what means from 0 to the end, but start from right to left. If I enter this, let me write anything. You are wonderful. If I enter, see, reverse it for me now. Let me give a space here, enter again. You are wonderful. You see, like this. You are wonderful. If I remove this evil enters, okay, hello. See, reversed. I can also put here input, and I come here and I say reversed. This should be here. If I enter hello world, this is input, this is the reverse of this input. Hope this is understood. Thank you for viewing. You are given a value or some values to check if it's or they are integers. Write a Python program to check. Remember, given. It means I'm going to accept input from the user. Enter a value. Okay. If I is digit, then what am I going to do? Print something for me. What am I going to print? Print that the I is an integer. This is for formatting, so I will say format I, because I will take the place of this. I can test it now. Let me just test it and show you. If I put 12 now, you see, 12 is an integer. But what if it's not an integer? I will say ends print is not an integer. Now, if I put this, it says not an integer. If I put this, it says not an integer. If I put this, it says an integer. You can also have a different solution as long as your output is able to detect if the given value is integer or not. Definitely, you are correct. How does the while loop work? Let's see. If I say, for instance, m is equals to 10. As long as this m is 10, do something. That is, while an expression stands, exists, remains, continue to do this statement for me. Okay, as long as m is greater than 12, print something. Let's see, print high. Nothing was printed because m is not greater than 12. But if I say as long as m is less than 12, you can see that it's less than 12. Print this for me. What this guy will do, it will continue to print I, because this m will always be what? Less than 12. That is 10 will always be less than 10. Let's see. See, it's printing it. So many of it. It will continue to print it forever until your system crashes. See, it's still printing. You can see it's printing. Let me break it. Stop. I've interrupted the system. It says as long as m is less than 12, do this. You will agree with me that there is no time m will not be less than 12. As long as m is less than 12, do something. What should I do? Print I. It will continue to look at this place. Is MC less than 12? Is MC less than 12? Is MC less than 12? As long as m is less than 12, it will continue to print this. Okay, let me say k is equals to 100. I say y k is greater than, say, 99. Do something. What should you do? Remove something from k. That is to say, k minus 1. Okay? Remove 1 from k. And whatever you get, put it as a new value for k. This one means as long as k is greater than 99, as you can see here, do this. Remove 1 from k. Then print the value of k. Only once. Why? K is 100. It check k is greater than 99. So they have told me that if k is greater than 99, I should remove 1 from k and print the value of what? Of k. When you reduce k by 1 here, the new value for k here now is now 99. And it check again, k is now 99, which is this. It's no longer greater than 99, so everything stops. Okay, let me put like 90. Let's see. As you can see, from here, k is 100 now, and we find that k is more than 90, it's greater than 90. Here it says what? Put the 100 here, put 100 here, remove 1, it has what? 99. Say print the new value. This 99 will be stored in k now, which will be here now. So here will be 99. Print it, it printed it. Now the new value for k here now is what? 99. Is 99 greater than 90? Say yes. What did it do? It's in 99 now minus 1. It had what? 98. This new 98 is now the new value for k. Here becomes 98. Okay? Printed. This new value of k, which is 98 now, is checked against this one. When it was checked against 90, find out what? 98 is more than 90. Okay? Therefore, you are qualified to come here. So 98 minus 1, 97. It had 97. So print the new value for k. This is now the new value for k, which will be here now, 97. This process will repeat till it gets to 90. When it gets to 90, you find out what? 90 is not greater than 90. So it stopped. One thing I want you to know is, as long as this is okay, as long as this exists, do this. If h is equals to this, get a printout of each of the object of h. If h is equals to this, get a printout of each of the object of h. Let's see. H is equals to this. We are asked to get a printout of each of the value of this. That is to say, we print 3, we print 4, we print 6 to 9, until there is nothing left for h. Look at this. What is the meaning of this? Why h? See, there is no condition here now. Before we say why, we put expression, and all the expression I show you before now, we are all conditioned. Like if s is greater than whatever, do this. Now we are saying why h. That is why h exists. As long as h exists, do something for me. What is that you want me to do? I want you to print these values. What can I use to print this? I will use pump. Pump is for deleting. So whatever you delete, I want you to print it for me. So I will say h dot this. Then I have to print this now. If I print this, I can put it like this. If I run this now, you see, starting from 9 came to 3. You see, start from 9 came to 3. Because by default, pump delete the last value, followed by this, followed by this. As it was deleted, it was also printed because I put this here. If you check h now, you find that h has no value. Now let's get this value of h again. Let's initialize it. I will copy this one to show you another method. If actually you want to start from 3 to 9, what will you do? You just tell the system to start from 0. Because this is the 0. If I run this now, you see, start from 3, go to 9. And if you check h now, you see, h has no value. Okay, look at this. I initialize again the value of h. If I put h here now, you see, back to normal. If I put this here, I can also tell the system to start from -1. That means -1 means start from the end, like from this side towards this side. Just what we have here. What we have here, we started from 9 to 3. Remember, the last value here is -1. I just want to show you that discipline means -1. Let me show you. If I put -1 here, now you see, it starts from 9. I want to start from in between. Let me see. Okay, I put this here. I say start from 2. I put this one as 2. That means 0, 1, 2. Start from 6. See what will happen now? We're definitely going to have error. You see? It starts from 2. 6, 7, 8, 9. Then it's giving us what? Error. So when it finished deleting all this, okay, h was still left with 3 and 4. But the system says, why h exists? Why h exists? And it found that h has some value. But this one restricted the system from starting from beginning. So it's show you an error that what? Pop index out of range. That means these remaining one are out of range because hope this is understood. Thank you for viewing. What is the purpose of break with y? Let me explain this with an instance. Assume I say it's equals to 1,000. Okay. I say y amount is greater than 500, what do you want me to do? While amount is greater than 500, continue to withdraw. How much should I withdraw? Continue to withdraw $100. How do I put that? We say amount minus equals to 100. Okay, as long as amount is above 500, you can be withdrawing $100 out of it. If I say print amount, each time you withdraw, you print it. Okay, if I run this now, I have the first time remove 100, have 900, has 800, has 700, has 600, has 500. This is perfect. So what is the purpose of break? Assume I don't want this withdrawal to get to 500. I want it to get to, let's say, 700. I don't want it to be below 700. And I don't want to indeed this, for instance. I can say, okay, while you are withdrawing this, if amount is equals to 700, stop doing what you are doing. I say what? Break. See, I know before now, this is what I wanted. But I'm not telling the system that, please, in case amount is 700, while you are withdrawing, in case it's 700, break, stop doing the withdrawal, stop the process. So what I will do, I will copy this new one. So what we do that, we say, okay, if amount is equals to this, you need to do something for me. Because I want you to do something, I have to also put what? This here. If you have not done if statement, you need to go back to if statements. So I'm inviting if now, otherwise. I know I want this. Be withdrawing $100 as long as the amount is above 500. But I changed my mind that, oh, please, if it's not equal to 700, break, don't continue. Okay? Still order this one. Let's see. If I run this, see, gets to 800, 900 first, 800. Once it saw that the amount is now 700, it stopped. So if I check what is amount now, you see that the amount is what? 700. So the new value for amount is what? 700. So once the amount is 700, break. Break is used to break a process. Why whatever I see is here, you can break something. So what is the purpose of break? This is why, right? And why is, as long as this is true, okay, do this for me. What is the purpose of break? Break is to stop a process through a condition. I'm telling the system here that as long as this amount is above 700, remove 100, remove 100. Then I went under this place, under this one. I went under this one, okay. When it gets to 700, stop the process. The purpose of break is to what? To terminate a loop. We are going to see more of this as time goes on. Thank you for viewing.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
I understand what you did in the just concluded challenge. However, what if you don't want 700 to appear in the output, but you want 600 and 500 to be part of the output? What it's saying is, look at this place. We started with 1,000. We continue to subtract 100 from this 1,000 until the amount was no longer greater than 500. Then we wait for that to say, let's break it at 700 because we don't want this withdrawal to exceed 700. So this question is saying, assume you want everything like this, but you don't want the 700 to appear. How do you do such a thing? You want everything to appear, but you don't want 700 to be part of it. What are you going to do? That's what the question is saying. Okay, what I will do now, we go back here, initialize this to be 1,000 now. If I say amount, it's now 1,000. So if I copy this, you agree with me that I will print everything like this. If I check the correct value in amount now, it's 500, but 700 is here. How do we remove the 700 while we still use this? Let's initialize this again. Okay, let's come here, copy this. If you want to achieve this, we have to use what we call what? Continue order if. How? I'm telling the system that I know this is 1,000. Continue to remove 100. But once you get to 700, continue. This continue means that 700 will not appear. Once you remove the first one, 900, remove the second one, 800, and it check, I found that what? It's not 700. Say no. If you are 700, it says what? Don't do this. It means don't come here. The first thing was 1,000. 1,000 is greater than 500. The system remove 100. It check, is this amount equal to 700? No, 900 is not equal to 700. This was not executed because it's only made for when this amount is what? 700. So it printed it 900. The new amount now is not 900. It checks 900 more than this. Yes, 900 is more than this. Remove 100. When you remove 100, it's 800. It checks this amount that is coming from this place. Is it equals to this? It say no, this is just 800. Print 800. You put 800 here now. You check 800, is it more than this? Say yes, it's above 500. Remove 100. When you remove 100, you check this amount. You find that when you remove 100 from 800, 700, that means continue means don't come to this place. Don't come down. Go back to this process. Don't print. Don't go down. Before now, all of them will move down, go back, move down, go back. But when it was 700, it didn't move down. It just came here. From here, go backward. So print was not used. When it sees that it's now 600, its amount equal to 700, say no. So this will not be executed because this is only meant for 700. So it printed. If you run this now, you see 900, 800. But when it is 700, don't come to print. Just go back and run this process again. That means don't go after this. All this understood. Thank you for viewing. In a simple term, explain the difference between break and continue. Break is like when the road of a journey comes to an end. When the road comes to an end, you can't go further. Everything stopped. Continue is lighter. Generally, one thing you should know about why is that this is what? Looping. You loop through. What is looping? You take this 1000, you place here, ask the system, is this 1000 greater than 500? You say yes. You go to the next one. Okay, if it is yes, the 1000 minus 100. Once you finish that, you print the value, which is 900. You get this. That means the new value now is 900. You loop again. You check, is 900 more than 500? Say yes. Amount minus 100, that's 800. You print again. You go for the next one, you go for the next one, you go for the next one. You are happy. So once you do for the first one, I say, wow, I got 900. Print. Second one, I got 800. Oh, I got 700. Oh, I got 600. Oh, I got 500. Once you get to 500, is 500 greater than 500? It is not true. You cannot be greater than yourself. You are equal to yourself. Then that is the end of the looping. Very good, right? Okay, good. Now, let's see break. Break. When you get to this place, if this condition is true, where you are applying the break, you stop the whole process, irrespective of what comes after 700. That is to say, when you loop for 900, you are very happy. This is not 900. You loop again, 800. This is not 800. When you loop again now, 700. This is 700. You stop everything. As far as this place is concerned, we still have 600 to go. We still have 500 to go. No, I don't want. Stop the process. Break it. Don't do anything. And get out of this place. Okay? But when it comes to continue, let's see. You did for 900. You are very happy. This is not 900. Wow. 800. This is not 800. Wow. Now 700. You find out this is 700. So when you were coming down here, looping, the system say, okay, is this 700? Say yes. Okay, what should I do? Continue. Continue what? Continue means don't come to this place. Go back to this place. Continue is flexible. Break is not flexible. Continue means if it is this value, continue for the other value that comes after 700 as far as this word loop is concerned. That is, continue for 600, continue for 500. What it simply means that once you see continue, don't go for codes after continue. Simply go back and do for the other one. Please leave me alone. Continue for other guys. It's not aggressive, but this guy is very, very aggressive. But this guy is not aggressive. He's a simple guy. Please, because I have 700, and whoever that did this program said you should continue. He's telling you to continue for others. Just leave me alone. Don't do anything after this continue for me. That is the meaning of this. After continue, don't do anything for me. Once I am 700. Once I am 700, don't do anything after continue for me. Simply go and check for order. And he check again and find out the next one was 600. And he asks himself, is this 600? He said no. Say, good, very good. I will continue this process. Then he print this, he print this. Why did he go after 500? Because when he check here, is this new amount 500 more than 500? He said no. Okay, therefore I will stop here. So the difference between break and continue is that one will break the entire process of looping as far as you meet this condition of 700. But continue says that as far as you meet my condition, it doesn't mean that I'm going to be the spoiler. You can still go for others. I don't care. No problem. Continue for others. Oh, this is understood. Thank you for viewing. Is there anything like one line while loops? One line while loop. Look at this. This will give us this, right? Okay. I want to copy this, put here, to initialize amount to 1000 again, and can do something like this on the same line. But before this one, I have to put what? Semicolon. Okay. Look at this. While amount is greater than 500, do this, then print. So I can separate these two with a semicolon. Everything on the same line. One line while loop. Let's see if it produce the same result. See? Same result. So we can do that. One line while loop exists. Between 30 and 40, find the numbers that are multiple of 3 and divisible of 4. Now let's see. Because I'm to start from 30, I will say s equals to 13. To initialize the starting point of x, I will say y x is less than or equals to 40. It will start from 13, but y it is below or equals to 40, do something for me. If I divide the number by 3 and there is no remainder, it's a multiple of 3. If I divide a number by 4 and there's no remainder, it's divisible of 4. That is the two ways we are going to use. Both multiple and divisible can be tested with what? Modulus. That is to say, if x modulus 3 is equals to 0, that means there's no remainder, and x modulus 4 is equals to 0. Okay? If this is correct, what am I to do? Print s for me. Okay? Once you print s, you need to go back again and increase the value of s by 1. I mean, remember, this 30 will first of all go through this loop. Once you finish with 30, I guess here, add 1 to 13. S equals to s plus 1, which can also be written as equals to 1. If we run this, we have 24 and 36.
This video is over. Go to starfreelance.eu to download these videos, materials, and sources. Watch more videos to get premium videos and ebooks. We'll be a Starfreelancer.